Hey people, welcome to the Skinny Coder YouTube channel. In this video, we'll take a tour of the complete Python programming language, and if at all you're a beginner, then well, you're at the right place. So stay tuned and let's hop in now. Okay, before getting into the overview of this video, let me make some things sure. Okay, so you should have Python installed on your system. You'll go to python.org and in the downloads, you'll choose whatever platform you're on and you can download the Python executable. And I'll be using Visual Studio Code as my text editor. You can pretty much use anything. So starting from terminal editors like Vim to IDEs like PyCharm, you can use anything. Even here, you'll go to code.visualstudio.com. You'll choose your platform over here and make sure you download only the stable ones, not the insider builds. Okay, for this video, I've made a get repo. Okay, so Python crash course, and this is my GitHub handle, the Skinny Coder. I'll be having the boilerplate code initially in the master branch. Okay, so in the master branch, I'll be having all my code files, which will be having the minimum code available, like how I'll be starting now with the code files. All those will be available here. And also there will be the overview and how to install VS Code on each platform for Windows, for Linux and Mac. So I'll leave the description of this link in the description below. So, and you'll also have how to install Python on all the three platforms. Okay, so using a package manager or going to their website and downloading them. How do you get the code? If you want to get the boilerplate code, or the code that you want to start in, that I will start now, and if you want to follow along, I recommend you to clone this repo. You can clone it here. You can just grab it here and go to your desired folder, and you can just use this git clone. If all this is not visible, let me make it. Yeah, so git clone and the repo thing. So we'll have both the branches cloned to you. So as of now, we are having only the master branch. So it will have the initial code. To enter into that, you'll have to type git checkout master so that all the initial code will be available. And now we'll shift into the complete branch called completed, and in that we'll make our edits, and we'll complete all the tasks given in the code files that are available in the master branch. And I'll commit this. I'll push this as a separate branch to the repo. So you can come here, and after this video is done, I'll do that too in the end of the video. So you can switch to that branch, or in your system, if you want to view all the code files while I'm teaching this video, you can just check out to the completed branch and you can get the final code. I have not created that branch yet, but you can so do it. Yeah, so that's pretty much it. I'll be minimizing it, and let me open my terminal, but I think I'll be using bash. Okay, so yeah, this is my bash, and on the desktop I have this Python basics folder. So that is our repo. That is the same repo that you see here, Python crash course, and all these files and these folders are available there. So in here, in here, let me get into that, and you can see it is showing me the branch master. Okay, I'm on the branch master, and these are all of the folders that are existing in there. There are some images in the readme file that you have just seen in the browser. Before I get into the Python basics and in the master branch, I think I'll have to create a new branch. Get checkout B to create a new branch and checkout, and the name is completed. Okay, yeah, so switch to a new branch called completed. Now I'm in the branch called completed. From here, the git tree, the plain master tree will be divided into two things. So now I can open Visual Studio Code in this folder. The dot shows that we're in the folder. So yeah, here you go, the completed branch. It is showing the so I think it's better if I zoom in a bit. Yes, that's great. Yeah, so let's get into the overview of this video. Cool. In the previous video, I think I've discussed about all these. Firstly, I'll be doing Python beginners crash course, which is this video, and later on I'll be discussing all these topics in one or the other videos too. And I've also mentioned that this list may keep on increasing, and there'll be a development environment setup too, like the Anaconda or PyPen or PIP, and pretty much virtual environments and everything. So these videos will be coming in soon too. So I'm actually planning to do a video to FreeCodeCamp too. Yeah, we are in the first part here. If you have watched my previous video where I've solved 2 lead code problems using the Python that you'll be able to solve problems after going through all these videos after completing this course in my YouTube channel. In that video, I've gone through this. So for this video, for this beginner's crash course video, the overview is this. So in the first module, we'll be discussing about comments, single line, multi-line, and what are doc strings and all of that. And in the second module, we'll go to input and output, how to take input in Python and use the print function and, give the prompts to user, and not pretty much everything related to input and output, but the basics of it. And then we'll also take variables and why do we call Python as a dynamically typed language or a loosely typed language, and I'll be discussing some theory stuff over there. And we'll get into the data types, the basic minimum data types that are available, and some falsy values and how are they related to all of the other data types and how are they pretty handy at times. And then we'll get into typecasting. So if at all we want to switch between the types, and if we want to convert between strings and integers, strings to floats and all, I'll be in the module 4. I'll be dealing with typecasting. And then comes operators. So in operators, I'll deal with arithmetic operators and comparison, logical, identity, and whatnot, all of them. And while discussing assignment, I'll also discuss the concatenation of the strings that I've discussed in the previous module. There are also membership operators, but I won't be discussing in module 5. I'll be discussing them when I get into data structures. Okay. So yeah, so discussed in data structures. Then we'll get into conditionals. This is where we first enter scope-based Python and all, the colon that we use to create scopes in Python. I'll be using the if and else, all of them in in a simple program that we write, so that I'll be demonstrating all these to you. And then we'll get into the longest part of this video, which is the data structures. I'll be trying to complete the maximum parts of these, but not all the inbuilt methods and all involved in these, but I'll be trying to complete the maximum, what are lists and tuples and how they differ from each other and all of them. And we'll also see their respective constructor functions, and we'll discuss the membership operators. Then we'll get into loops, because actually I could have completed loops before getting into data structures, but in Python we write most of the loops on data structures and using range functions. You see, using the range or related to, we'll iterate on these data structures. So I think I should have first completed these and then get into this. So I think we'll be doing it as 8th module, the for and while loops, and how are the range functions so hot in combination with for loops. And we'll also go and discuss about the break and continue statements. Okay, then I'll get into Python functions. I'll not discuss too much about it. Only the what are the types of return values, and how many parameters you can pass or arguments you can pass. And I'll introduce you to the pass statement too. I can use the pass statement in conditionals and in loops too, but I'll be using this as an opportunity to revisit them and use them in the functions that we write here. Okay, I won't be discussing complex concepts of functions. The very basic. This is the shortest module, because I'll be having a very in-depth video about functions in Python in this series. So I'll be discussing functions which are just as far as the crash course and the beginners are considered, they should do. Okay, only those functions I'll be discussing. And then we'll get into oops. We'll discuss still inheritance. We'll not discuss concepts like static fields and getters, setters, and some stuff of that sort. Then we'll get into exception handling. We'll write the try catch and how to raise some statements or raise some exceptions, and we'll also see some inbuilt exceptions. I won't be teaching what is the finally block or the else clause in here, or the else clause in loops, or how to write our own exceptions. I won't be discussing all these in this video. And we'll get into modules, how to use the import and how to write aliases to them, and how to use the from statement and how will it make a syntactic change while using the from statement in modules. Okay, so last 2 modules will be having multiple files in them. So in the file handling, there's the final structure. We'll be learning how to open a file and also how to read them. Okay, so we'll be discussing all of them. That's pretty much it, guys. I think we'll step into the video now. Before getting into the first section, which is comments, or the 0th section to be precise, I'm using Python 3.7.5. You can use any version, doesn't matter. Also, in the first, while running the comments and all these files, I'll be showing how to run via the terminal. And after that, I'll introduce you to Visual Studio Code's tasks and tasks.json files, so that you don't need to keep on doing those, compiling the file and running the file, or in Python terms, if you have to call it, interpreting the files each time you made a change and you want to do it. Oh yeah. first comments. So you see these hash symbols over here, some people call it bang and some people call it hash. This is how we make comments, okay? In most of the text editors, you can use control and slash to comment and uncomment them. You see, I can toggle it that way, or I can go to the and just delete it that way. And obviously is a keyword in Python, that is why it will be showing, it will be syntactically highlighted, but this and a and comment, these all aren't keywords or some statements in Python. That is why they'll be underlined and raised as warnings and all. You write code, and if you don't want the interpreter to read that line while Python while executing line by line to read by the interpreter, then we just comment it that way. Now this will be avoided. It will be used for documentation purposes. Let me just make it okay. Yeah, okay, that should do. So what I'll do is I'll toggle my terminal now. So I'm in the completed branch. By the way, I'm using Z shell. You can use bash too. That doesn't matter which shell you're on. Even on Windows, you can use command prompt or PowerShell or anything. Yeah, how do I run this? First of all, I'm on the Python basics, and if at all I see what are the folders, 0 and comments. Yeah, now I'm on the comments folder. So I have the comments.py file in here. So to execute a Python program, I write python 3 comments.py. Okay. Now I get nothing because everything in here is just commented that way. If at all I take this comment out and I save it, and now you see you don't need to keep typing that python 3 and the file name. By the way, to run this file, you'll have to be in this folder, or if at all you're in this folder, you should be like python 3 and 0 comments/comments.py, because you'll have to provide the relative path from which folder you're in to the file you want to interpret. And also you don't need to mention python 3 if you're on Windows. You can just write Python. It is for only Unix systems, I mean for Mac and Linux. I can just press the up arrow and the previous command appears here, and I can do that. I'll get a syntax error because obviously this is syntax error. These all words and keyword are not keywords or identifiers in Python. So if I don't want them that to read by the interpreter, and I'll just comment it that way. Okay, so that is how we write a single line comment. Okay, so whatever I write after that, if I press an enter and whatever I write, again that all isn't comment. Okay, so if at all we want to write another comment, we can just write the same stuff and I can comment that too. But at times you find that very annoying, and you don't want that to look like a hash symbol before everything. You know that the next line will be also a comment for sure, and why do you just want to comment every single line when you have the concept of multi-line comments, or which are also known as doc strings. Okay, so doc strings are mostly used for documentation purposes. Let me also introduce you to this actually, the Python extension in VS Code. You'll have to have this enabled on your system in this VS Code, or else there will be no syntax highlighting and all those. So yeah, so that is it. Yeah, we get a syntax error, and if I run this again, I don't get a syntax error because nothing is being run in my code because everything is commented. We can use the multi-line comments like this. You see, we can just press use 3 quotes, or we can also use 3 double quotes. These are 3 quotes, and for example, I write something over here. It doesn't really matter whatever I write there, and in the next line I again put those 3 quotes, and now this is a multi-line comment. Okay, all these which are between these 2 single quotes are multi-line comments. We can also use 3 triple quotes. Okay, so even those will be considered as multi-line comments. It doesn't matter what you are using in Python. You can use the 3 single quotes or 3 double quotes too. All the things that are wrapped in between these 2 are considered as multi-line comments. Okay, so these are used for documentation purposes. Use it like comments, multi-line comments. Okay, so let me add a comment over here. We can use single or double triple quotes. If that sentence is quite complicated, we can use the single triple quotes, or we can also use the double triple quotes. Okay, yeah, so that is it with comments, guys. In the next module, we'll be discussing about input and output functions. Okay, so now let us get into input and output in Python. We use the print statement for outputting variables, printing them to the console, and we can run this file, and we'll be seeing the hello world printing to the console, and we'll also see to print 5, 4 and 10 in an order with space separated by default. They'll be printed to the console. Okay, we'll be using this, and before executing that, I'll be commenting out the input function and all, because I'll be coming to that in a bit a second. So first, let us do this. So I'll toggle the terminal again. I'll switch into my one underscore, I think the folder name is input output. Is it? Yes, it is. Now I'm in here, right? Input output, and there is a file called that input output. I can do Python 3 input output.py, and when I run that, see, I get hello world printing to the console. This is the console. You can see the prints a stream to the standard out by default. This is a standard output, and we use the input to give the input function to give the standard input, and the print function will be printing it to the standard output. If you are passing multiple parameters in there, all will be printed to the console by default, space separated. We can change if you want to add some columns in there, or in the separated lines, if you want to add a slash in between them, we can do that too. I'll be not getting into too much of pretty printing and string formatting and all this. We'll have a dedicated video for that. But as far as the basics are concerned, we'll be using the print function. It will take a single parameter to many parameters. If you pass how many parameters you pass in, those all will be printed in the same line as space separated whatever we pass in. Okay, I'm passing a string over here and a group of numbers over here. Okay. See, this is very tough to do it, right? I'll have to go to the folder and type the file name, and I can't even tab complete these, because in VS Code we'll be having tab for other keyboard shortcuts. So what I do is, I have this .vs code folder which won't be available on the GitHub repo, because I'll be ignoring it in the gitignore file. This won't be pushed to the repo. So in here I have a task.json file which just does nothing. It does the same thing whatever we are doing here. What am I doing? I'm typing Python 3. The command is Python 3. And what is the file that I want to compile? The name of the file is a there is a variable for the file that we are currently operating on in VS Code, which is this. Okay. Yeah, you can go through the documentation of VS Code if you want to get to know more about. You can go to docs over here, and what are the tasks.json file, and you can go to Python and all. If you don't want that to happen that way, there is a pretty simple way to do that too. We have a green symbol over here. You can just press that. You don't need to write a task.json file for this. You can just use this, or you can right click and be like run Python file in terminal, and it will run that. You see that hello world and 5410 both are being run. It is doing the same thing that we are doing, Python 3 and the complete path of the file input output.py. Okay. This comes more handy, but I like writing my own build system instead of the one provided by the Python extension. So this is by default provided by the extension to run the current Python file in the terminal. You can also click the green button over here. It does the same thing too. But I like to write my own build system, so I did write it in the task.json file. So I have a keyboard shortcut embedded for that. Okay. If I go to keyboard shortcuts and the JSON file of it, I have ~p to write to run my task. Okay, the arguments with Python. So in the task.json file, I have mentioned it all, and I've set up ~p, which if I run now ~p, it will just run my file. Okay, it is executing this task which I've mentioned in the task.json file, and it does the same. Okay, I'll be using this. You can use the green button, or you can right click and do that too. Okay, it doesn't matter. So this is how we print to the console. We do the output in Python. Okay. Now let me comment this and get into these. What is this? Input is a function which reads a string from the standard input. Like it will be while you're running the file, the cursor will be blinking over there where it will be expecting an input from you, and whatever you type there, it will be taken by default as a string. Okay. Mark this. It is really important, because input in Python is not like the same in other languages like C, C++, Python, Java, and all of those, where you have the type of the input that you're taking, or the type you're printing, or the type you're operating on, to be precise, are statically typed, or it's a type specific language, and Python isn't. So everything you take in or you print out is by default a string, and if you want to typecast them, we'll be getting into typecasting in the fourth module or so sooner. First of all, let me just take in x equals to the plain input function, okay, and I'll comment the below line because I don't want to introduce you to prompts already, and I'll run this file and it is expecting something. That is why nothing is being printed to the console, and there is no completed. You see, you can click, you can press any key to kill the terminal, that will be coming down, but it is not done yet because it is expecting an input from us. If at all I press 5 and enter, now it is done. Okay, we are not doing anything with the variable 5, it is unused as of now, but this 5 over here is a string. Okay, if you want to check that, we have an inbuilt function in Python known as the type. Okay, so type of x, whatever you pass in the parameter of it, it will check the type of it. Okay, so it is of the type, x is of the type str, if you see there. So str is the data type of string in Python, and the class string will be printed to the console. And if you want to print x2, you can do it that way, or I can just, as I told you, I can just put it there. Okay, I don't need this. And now when I run it, I give for example 5 again, and you see that this is the data type. The type is, it belongs to the class string, and the value is 5. It's space separated. Or if you want to be very precise, I can also give my name. Okay, Rahul SriRam. By the way, I'm giving a name which is having a space in between. All of it will be recorded, unlike in some programming languages where until a space will be taken. But since it is a string that we are taking in, or the complete line, whatever we are passing, until an enter is pressed or until a /n is encountered, it will be taking that as a input. Okay, yeah, so we can give anything and it will be just of the class str. It will be taken by default as that. Okay, but what if you want to give a prompt to the user? You know, like as of now when I run it, you're not, oh sorry, not this. Yeah, as of now when I run it, you're not seeing anything, right? But you can give a prompt to the user by something of this sort. You know, to the input function you can pass in a string which you want to show in the console. So after this we'll be getting the console will be blinking there, which shows that an input is being expected from the user. Okay, now when I run this, see, enter your name, and the cursor is over here. Whatever I type here, for example I type 45.5, which is a float, and it is again a string, but the value is now 45.5. Okay, so this is how you pass in prompts to the input in Python. Okay, so this is it with input and output, and I think we'll be going into the next module now. Okay, so let's get into the next module, which is variables. Okay, so in Python, variables, while declaring them, we'll have to initialize them. Okay, by default, we'll have to initialize the variables. We can't just declare and leave them. So because it is not a declarative type of language or whatever, no data type is required. So what does this mean? Okay, there is no requirement of mentioning the data type. For example, I'm assigning x to an integer, which itself is deciding as an integer. I'm not writing something like in programming, like other programming languages, or because most of the students are pretty familiar with C, C++, and Java. We do something of this sort, right? Int x equals to 5, and that is not how we do it in Python. We don't do that here. So what is it? What is it actually happening here? Based on the assignment that we are doing, the data type of the variable will be inferred, and it will be taken from the right hand side of the assignment operation. So that is why we can't just declare a variable like this x and I can't operate on it in the coming statements. Okay, by default, while we are declaring, we'll have to initialize it. So we'll have to declare and initialize it. By the way, we have already used variables in the previous module in input and output. We are taking the input over here, which is a string, and we are storing it in a variable called x. Okay, and we are printing that x to the console. Okay, so we can print values like this, literals like this, to the console directly, or we can print some variables which are storing some values or which are storing some literals to the console too, and those will be printed. Okay, yeah, so let's get in here. So there are some naming rules in Python. By the way, Python follows snake case. By, you know, there are many types of cases. For example, this is known as camel case. The first word will be small in letters and the first letter of the second will be in the capitals. This is mostly preferred in Java and JavaScript, and some follow capital and capital again, like this in some programming languages. I think C#, I'm not quite familiar with it, but Python takes in like this. This is known as a snake case, where we keep on using underscores. Underscore is like pretty much used everywhere in Python. So yeah, naming rules that is not a naming rule, that's a naming strategy. People mostly name it that way. So the names of whatever we name here, the variables, or in the future or in the coming modules of this video, we'll be discussing about functions, classes, and everything about that, where we'll be coming through many keywords, and all these are known as identifiers. Okay, keywords are not identifiers. The first thing is that they can only contain alphanumeric characters and an underscore. Okay, but by alphanumeric characters I mean capital A to capital Z and small a to small z, all of them covered. That's 26 into 52, I think. And then also the digits 0 to 9 and the underscore 2 and nothing else. Okay, no other character is allowed in naming these variables. And it is case sensitive. Small x is not the same as capital X. So these are the naming rules. I think these are the basic ones, and there are some other rules too, but I think they will be covered in this. And yeah, as I mentioned, variables can't just be declared and left. They have to initialized at the time of declaration only. We are declaring a variable here, and we are initializing it using the assignment operator. We'll get into operators soon. I can assign values to this. Okay, now I can print. You see, this is an extension to the input output. Print function can print the variable's value, like the value of x is 5, and that will be printed to the console. Or it can print the value itself, like I have already told you. We can print the literal itself, or we can print the literal by using the variable in which it is stored. Okay, both are the same. It doesn't matter in what way we're doing it. And we can also reassign values, assign another value. Okay, for example, if here I'm taking x as 5 and here I'm taking x as 6. Okay, so again, if I print, for example, first let me demonstrate that and show you 5 obviously, and if I print a 5, it will be 5 always. And but now if I just reassign it to 6 and print that, and I don't think I'll be needing that literal to be printed to the console, and if I run this, I get a 6. You see that the value is by default changed, it is overridden, and x is no longer 5. Okay, so now what do I mean by dynamically typed language? Okay, so the data type of the variable is dynamically chosen. It is not statically typed in front of the variable int x or string x. We are not going to do that. So based on the RHS value, that will be inferred, and that will be assigned to that data type will be assigned to the variable. And this comes in handy while we want to reassign something of which considers or which comes under another data type. For example, here x is an integer. You see that, because we are assigning an integer to it. But now I can assign a string. Okay, for example, my name Rahul. Okay, now when I print this, it will be printing Rahul. Okay, now if I come to x, it will be a string. Okay, because though it is reassigned, the same variable is being reassigned, but we are assigning it to another data type, and this is pretty much possible in this language. In statically typed languages, if you are taking int x and we are assigning x equals to 5, then we cannot go and be like x equals to some string. Okay, that will raise an error. But in dynamically typed languages or loosely typed languages, it doesn't matter. Variable reassignments and the literal reassignments can be interswitched between the data types too. That is pretty much possible. Okay, so now let's get into data types. Okay, so the third module is data types. What are all the data types available in Python? First, I'll be discussing strings. So I'll take a variable called myString, and we can use the single quotes. For example, let me use my name over there. And I think before I do all this, I'll just comment out everything, because I have some print statements in my boilerplate code, and I'll uncomment only this line. Okay, now I can print that myString to the console. Okay, now when I run this, I get Rahul SriRam in there, because I'm storing it in a variable called myString. Okay, so we use the single quotes, and whatever we write in here will be considered as a string. I can also use the double quotes. Okay, so even that will be considered as a string, it doesn't matter. And we can also use the triple quotes, where, as I've mentioned in doc strings, I can use the triple quotes with triple double quotes or triple single quotes. Anything is possible. Okay, so now even this is considered as a string, because see, if at all I'm not assigning it to something, that is considered as a comment. Okay, and there is no variable called my string, so we'll get an error over there. But this 9 is not an error because this is a comment. But if at all I'm assigning it to a variable, this is not a comment, this is not a doc string, I mean this is not a multi-line comment, but it is a string variable. Okay, so if you are assigning it, it's a string variable. If you are not assigning it, it's considered as a multi-line string, multi-line comment. I can use the triple single quotes too, and it doesn't matter. We can initialize strings in all the 4 ways. I'll be sticking with single quotes because that is how I do it most of the times. Now I run it and I get Rahul SriRam. Great. Okay, so what if you want to find the length of the string? There is a method for that. Okay, we have print length of Rahul. The length function takes in something in there, any object, and it will return an integer value, the number of characters in the string. Length can be used for complex inbuilt data structures like lists and tuples, all of them too, but we can use them on strings too. Okay, so we've already seen strings in input output. Whatever we are taking here, x, is a string by default. Okay, that is what we taken from the console. Now we're done with variables too. Yeah, in data types. So what is the length of the string Rahul? Or I can just use Rahul in there, which is 5 because the length of Rahul is 5. Or I can just copy the line and I can find the length not only by doing that, passing a literal in here, but I can also pass in a variable to this function, which is the my string. And now if I do that, I get Rahul 5 and SriRam is 6 plus 1 space character, which is totally 12 characters in length. Okay, so yeah, so length of my string is 12. Okay, yeah, so these are strings, and that's pretty much it to the basics of strings and all. Now we have other data types like integers. So what are integers? Integers is what we have seen while the int data type. For example, I'm taking an x and I'm assigning some data type which is not having a point in them. Okay, like anything after the point, or there is no point involved in that. Actually, there is no much big scope or how do I say range in the values, the scale of values in for integer data type. Okay, like in other programming languages, it is very quite specific from 2 power minus 8 to plus 2 power 7, kind of some I don't know the range specifically, but they are being mentioned. But in here in Python, there is nothing of that sort. We can do it between any ranges. Of course, between some small numbers, there will be some changes. I'll be discussing them where I'll be discussing the math module and inbuilt functions. There will be getting into what is the difference between big numbers and small numbers in Python, and how performance related issues can be rolled out using them. Okay, but as of now, there is no small and big data types. Anything will be taken into this, and I can just print it to the console. How big is it? It doesn't matter. I get that number in the console. Okay, it will be of the data type integer only. Okay, I can also take that there, and yeah, even that is an integer. Okay, this looks good, right? Let me just put that there. Okay, yeah, so these are integers. Now the other data type is floats, which is a floating point number. So what are floating point numbers? For example, I have my float, and this is an integer, right? And even this is an integer, and minus 5 or minus 57, everything is an integer until and unless there is a decimal point mentioned in there. So if at all I am having a floating point in there, be it a long one or a short one, I mean a float or a tuple in other programming languages, but in here, if at all I type 5.5, and that will be taken as a float. Okay, that will be inferred as a float, and I can print it. Okay, my float, and when I run this, I get 5.5 over there. Okay, I can also use the type function to check the type over here, but I'll get into that later. And let me rename this guy over here to my int, because I'll be pushing this into my GitHub, and if at all anyone is interested in having this code as I'm teaching it, I want it to be pretty neat. Okay, now let me comment this again. For example, by the way, this is pretty new to Python. If at all we want to use bigger powers, most of the time floats are used as powers of something, like quite very small decimal values or very big, huge decimal values. We can use the syntax where we use the small e and capital E. For example, float 1 in here, I'm assigning it to 1e5, where E is a shorthand notation, where it quite refers to the power of 10. Okay, whatever I pass it after E will be considered as the power of 10, which will be multiplied with the thing that we are passing before E. So it will be 1 star 10 power 5, which will be 10 power 5, and if I run that will be 10 power 5. And obviously, since it's a float, since this syntax gives on a float, you don't need to mention a dot over here, or it will be considered as a float. I can typecast it. I'll be coming into typecast later. Okay, yeah, so this is a float, and it will be having a decimal by default. Even if you pass in integers, and if you want to print if you typecast them into floats, we'll be having that 0.0 at the end. So I can do it again, like it can be of the power 3 and or minus 3. Why always the positive numbers? And it can be 2. Okay, and here it will be minus 3, and this will be 2. Okay, now this is F2. I hate that. And print F2. Okay, yes, that's great. Now if I run these both, I have that one, and 2 into 10 power minus 3 is 0.002. Okay, so not usable for small powers like this, but when we are dealing with huge powers of 10, like 10 power 10, 10 power 50 and all, this comes in pretty handy. I can also use the capital E character over here. It is the same. Okay, it's pretty much the same, the capital E or the small e. Okay, so these are floats. The other data type is complex. Cool. So what are complex numbers? In some other languages you'll have to include headers, complex, or import a module and all, but in Python it comes in by default. If at all I'm not passing that, C1 will be considered as an integer. Okay, but if I'm having that, where this will be the real part, and plus or minus, or even this can be plus or minus, because the real part or the imaginary part, it can have any sign. But the imaginary part should be appended with a j. Okay, and this is the magnitude of the imaginary part, and now it will be of the data type complex. Okay, so these are some complex numbers, and if I print that over here before doing this, let's just print them and see, and we get that. Okay, 3 plus 2j, which is a complex number. Now if at all we want only the real part of that, or if at all I want only the imaginary part of that, I can use the properties of that complex number object. By the way, in Python, every data type or every variable, whatever you are taking, every variable, every object you create, every instance of a class you create, everything will be considered as an object. Almost everything, not everything, almost everything in Python is an object. Like 99.9% of it is, everything is an object. So every object will have properties and methods. We'll discuss it in the OOPS module in this video, but as of now I'm just giving an overview, so that every object will be having some properties. Real is a property. If it is a method, it will be a function. We'll be discussing functions too. So if at all I type c1.real, which gives only the real part of it, which is 3, and this will be returning floats. Yeah, I can go to docs here. This is due to my kite extension over here, and you should have that kite software installed on your system too. So this is kite, and it will give that mini documentation over here. Okay, so real part of the complex will be getting out complex.real. It will return the real part of it. This will be inside a doc string. Okay, you see whatever you see here, it will be inside a doc string, return while declaring this dot real in the class of complex and all. Okay, yeah, so that's it. And the imaginary part is 2.0. Okay, I can change the value to C22, and it's pretty much the same. We'll get the real part and the imaginary part. Okay, so these are the 4 most important data types, the strings and the numbers. And to check if the data type of anything, as I've already told, we can use the type function. Okay, for example, if at all I want to check print not type error, type of what is it variable over here, let me uncomment some other variables, for example C2. Okay, I'm uncommenting it C2 and I'll pass in C2 as a parameter. This type takes in the parameter C2, and if I run this now, it will get the class complex because that's the data type of it. Okay, yeah, so we use the type function. I have already mentioned this. And the second note is none. There is a special data type in Python called none, where none will be considered as a complete whole new level data type. It is not any other data type, where empty or undefined and null in other languages, if you consider, it is anonymous and equivalent to them. And now if I run them, wait, let me just comment this and run this. Yeah, see that the my none value is having a value of none, and the data type of it is a none type. None type is the data type of a none value. The n should be capital. It is a keyword. You can't just write like this or and all. N is a capital over there. Okay, that's keyword for none. Okay, let me comment that too. Now that we are done with this node, the fifth data type is booleans. What are booleans? There are only two values, true or false. Again, like none, true starts with capital T, and I can have a false too. Let me name it other boolean. Okay, it's a false now. Okay, we can store them here, and I can print bool other variable, both of them, and I do that. It's a true because bool variable is a true, and it's a false because bool other variable is a false. Those are the values. But if you want to check the data type, we will get the class of bool. Okay, these are booleans. Only either false or true will be there. Okay, great. So what are falsy values? Falsy values are something which we mostly use in type conditionals and all. We'll be getting into conditionals, like the if statements and all, where if a condition is satisfied, it will be decomposed into a boolean. If the condition, the boolean will be true, of course, if it is satisfied, and if it is not satisfied, it will be decomposed, or it will be reduced to all the complex expressions we write in there. The programming expressions we write in there will be reduced to a boolean value, either true or false. And we can't just always write in conditions over there. At times we might be having some special values like these are known as false values. A none is a false if at all I write if at all I pass this as a condition to a conditional, or an if or an else statement, else if statement, and that will be considered as false. Same, obviously false will be considered as a false. A zero integer or a zero float or a 0j, which is a zero complex number, or it can be 0 plus 0j also, it doesn't matter. If at all I'm not writing the real part also, it is a complex number. Or strings too, obviously, or these are two. Okay, yeah, all these are strings. All we can mention it in any way. And empty lists or empty sets or empty dictionaries and empty tuples, these are data structures. Will be coming into the, all these are considered as false. Okay, after a conditional or in a loop or wherever you're using, this will be considered, or this will be by default converted into typecasted into false data type, false boolean data type. Okay, so yeah, that's pretty much it with data types module. I think module number 3, and next we'll get into typecasting. Okay. Okay, so the fourth module is typecasting. The data types that we have been seeing so far, they can also be used as functions. Okay, by functions, I consider them as some entities which take in some parameters, like they're similar to mathematics functions and all, and they'll be returning us something else. Okay, first let me comment out everything, because that's what we should be doing in the first thing. I'm having a my integer. Okay, my int equals to 5, and when I print that, I get a 5, obviously, because that is an integer. Okay, but I can also write it this way. If I wanted it to be very specific and very precise, I can just typecast it using an int. I'll wrap the number that I'm passing it in here with an int. Okay, and I don't need to do this. Okay, because by default it will be inferred as an integer. I don't need to wrap it with the data type int, because it will be by default typecasted into an integer. Okay, but here because there is something like data type precedence and order of narrowing and widening concepts and all of them. So floats or strings are bigger data types when compared integers. Okay, so if I want to convert them back into integers from a bigger data type like float, then I'll have to wrap it with an int. So now it will be considered as an integer, or only the integral part of that float will be taken. And now if you see, my int will be just 5 and not whatever that is there after the printing that. And it's not even 5.0 by not considering the decimal part, not considering the floating value part. I'm not saying that it will be discarding 0.5 and it will return a float. It will return an int only, so it will return a 5. Okay, so I can also take a string. Okay, but I can't pass in a string over there because a string can't be typecasted in integer. We'll come into that too. When I run that, again it will be type of my int. It will be again an integer only over there. So I can just copy this and write before every print statement over there, because I think it will be pretty much useful. When I run this, see that here I'm passing a plain integer and the type is integer. Here I'm passing a float, but it's typecasted into an integer. Here I'm passing a string, but still it is typecasted into an integer. All the three are integers. Yeah, that's correct. Now I can also pass in a boolean. Okay, I can also pass in a boolean, and when I run this, the boolean true will be converted into 1. Okay, because 1 is the analogous boolean to true, and if at all I take a false over there, and it will be typecasted into 0. Okay, still it will be of the type integer only because I'm typecasting it. So similar to this, but what's wrong in passing some string? Okay, for example, I pass this to, I want the interpreter to convert this into integer, and obviously it isn't possible. We'll get a value error because we can't pass in something which is not having which is not in value equivalent to something, an integer of the data type. Okay, it should be convertible, so we'll get a value error. So to avoid errors like this, we'll be getting into try except blocks and error exception handling, and we'll be discussing it in the future modules. Okay, so this is how we convert other data types into integers. Okay, so let me comment out this. Yes, now let's get into floats. Let me uncomment all of them. So I'm having a float. I don't need to write a float function over here to, because by default it will be inferred. I don't need to do that, but it's pretty much your wish. I can pass in an integer here and it will be converted into a float, and it will return 5.0, though we are passing just 5, and I can give an integer or float over here, that doesn't really matter, and it will be converted in the data type of string. And obviously again it shouldn't have something like the skinny coder and all in here, because a string can't be converted into a float. Only numbers which are having points in them can be converted, and a boolean can also be converted into a float. So let me now run this. You see 5.5 by default is a float. I don't need to write that, it will be 5.5 only. And though I'm passing 5 as an integer, I'm getting 5.0 because it's typecasted. And if I'm passing 5.6 as a string, it is converted into 5.6 as a float, and a true is converted into 1.0, unlike in the case of integers where it was 1. Okay, now if I can't convert this in false, I get 0.0, and I can also pass in a 5 here, because an integer can again be typecasted into a float, and it will be a 5.0 only. Okay, though I pass 5 as a float, as a string, or 5.0 as a string, it doesn't really matter. Okay, it will be converted into a float only because we are applying the float function over here. And now the other thing that I want to discuss is, I think I can also pass this in here. So you remember this syntax 3 or 2 to be precise, to be the exact same thing what we did, which is 2 into 10 power minus 3, and if now I run this, I get that. You see that that's typecasted into a float and it's written like this, though I'm passing it as a string. Okay, so yeah, that's pretty much it, guys, to converting other data types into floats. Now the strings, cool. There is a function called str. Str is a class which will create a string object for us, and we will take a parameter as a data type, and it's similar to other data types too. Here float, or if we comment it to get the intelligence, here a float is a class or a constructor function. Obviously constructor functions will have the same name as the class, so whatever is the parameter that we are passing in there, it will create an object of that class and it will assign it to the variable. So that is what is happening here. We'll come into constructors and objects and classes in the later part of this video, but yeah, so that is what is happening. Similarly, we can that is how, so we use the constructor functions to typecast it. So the same things will be applied on data structures too, where we will be discussing lists and tuples and all. So here we are having normal string, and it will be a string by default. I don't need to type an str and pass it, and if at all I pass a normal integer, it will be considered as a string. I think it's better to print the type, what's wrong, type of my string on every line. I copy that over here and over there. Cool. So when I run that, see that? So the first thing is obviously a string, a hello. I'm just printing it. And the 3, the data type is a string, but the value is 3. And 5.6, the data is still a string, but the value is 5.6. And the data type is true, and the value is also true. Okay, but it's a string in there. Okay, that's great. So these are how we convert into strings, other data types of strings. This is pretty blunt. There is nothing in converting and doing like I pass in this and it will be returning 0.002 and nothing like that. Whatever we pass in, that will be returned in the quotes format. That is a simple typecasting for strings. And booleans, yeah, remember I've discussed falsy values. We'll be using them over here. A normal boolean will be like this. I think it's better if I again print the type of my bool. Oops. I copy that. Wherever I'm printing my bool, I'll be needing that. Okay, that's great. Now you see, when I run this, the first thing is obviously a bool because I'm assigning it to a true, and I'm taking an integer and it converting it to a bool, and the data type is a bool, and it is converted into a true because it's not a falsy value. I think it's better if I can data types booleans and some falsy values. This I want to open to the right and then close this out. And where am I? Yeah. So what are the falsy values? None, zeros, and empty strings or empty data structures. We won't be using those here. But yeah, 5 is not a zero, right? It's a non-zero integer, so it will be converted to a true. Okay. And similarly, 0.0 is the 33.3 is not a non-0.0 floating point number, so it will be converted to a true again. And similarly, a string over here, it is not something of an empty string or anything. There is no space in here, by the way. Space is a string, it's considered as a string of length 1. There is no string, we are closing it and we are opening the braces and just quotes and just closing it, that's all. That is known as an empty string. It is not an empty string, hello world is not an empty string, so again it is a true value. Okay, so yeah, that's pretty much it. But if at all I do the reverse, if I take false in there and the value 0 in here and the value 0.0 in here and an empty string over there, all these will be converted into false now. Okay, everything will still be booleans, but this will be typecasted to false. Okay, so this is where we'll be using falsy values and all these. There are many true values, you can't remember them, so I thought why not do the reverse. We'll just remember the false values and we can, everything which doesn't come under this list will be a true value. Okay, that's it. There are some other things to discuss too, like we are done with numbers and the basics, the pretty basics of Python, the very basics that any general developer should to know. in Python, we're dealing with numbers, strings and all. So all those we have done with them, but unlike we have seen the len method or the type method and all of them, there are other methods too, like absolute, power, def mod, factorial and all. These are the standard library methods, not in some module or anything. And we're also having a module called mathematics, which is completely related to the numbers data type, integers and floats. So pretty much very good methods are there in the math module. We can use those math module methods and functions and constant to solve numerical problems. And we have discussed strings, but we have not gone through string manipulation functions like f strings and format and splitting them, joining strings and finding substrings and all. All these we'll be discussing in the upcoming future videos, as I've discussed. See, I've already mentioned that in the series. This is a crash course and we'll be discussing in the later videos. Okay, yeah, so I think this is pretty much it for this video, guys. Let's meet in the operators section. Okay then folks, so now that we're done with typecasting, let's get into the fifth module, which is operators. Okay, so yeah, there are many types of operators. We're having arithmetic operators, assignment and many of them. So how do we deal with them? And mostly arithmetic operators are used for the numbers data types like int, float and complex only. So we'll take in a variable called mySum and we'll add two numbers in there. Okay, 1 plus 2. And if I print that mySum variable, we'll be getting 3, obviously, right? Before doing that, let me comment out all the file and let me just uncomment these both statements. That's great. Now when I run this, I get 3, obviously, because I'm adding two literals and I'm storing it in a variable, and I'm able to do it over here, or I can also do it over here. It's pretty much the same, it doesn't really matter. I'm not using the mySum at all, but it's still calculates the sum of them and it will return the value of there. So this is arithmetic, that whatever we are doing here. And we can also perform arithmetic on variables. For example, x equals to 1 and we have y equals to 2. Okay, and I can add x and y, and I can use mySum over there and it still be the same. Okay, so the values will be added and the sum of the values will be printed. Okay, so we can use all these operators in here. For example, if I have a minus, we get the difference of them, and if I use a star, and I think to demonstrate that it's better if I have a 4, right? So it will be 8. Obviously star is for multiplication. We use 4 2 8. That's great. And we use this to get the quotient. Only the quotient? We'll see. No, we get the decimal. Like it's the absolute, the complete value, not the only the modulus of the only the integer value of the quotient that we are getting, not anything of that sort. If you complete the perform the complete division and everything you get as an answer in decimals, it will be returned by using this. But if at all you want only the quotient or only the remainder, then we have two other more operators which are not new to Python but pretty much used. We can use a double slash operator which will return only the quotient. Okay, now only the quotient is 2, right? There is no decimal part or there is no remainder part available. If at all a remainder is greater than 1, obviously it will be appended to the quotient, right? So that's pretty much basic mathematics. To discuss it more precisely, let us take a value which is not completely divisible by 5. So if I now do it, the quotient is 2, right? Because it is 2.5, like 0.5 is the remainder and 2 is the quotient. We get only the quotient by using this operator, but by using this operator we get the exact result. Okay, and if I want to get only that 0.5 or only that remainder, I can use the modulus operator, which is pretty much there in other languages too. We get 1 is a remainder and not 0.5 because that 1 is also being divided by 2, and that is what is being given to us in that division operator. But here 1 is exactly because the maximum number that can be divisible by 5 with divisible in 5 below 5 with 2 is 4, so the remainder is 1 obviously. So there is this operator 2. We can use the double star operator to raise x to a power of y. So now this will be 5 power 2, which is 5 square, which is 25. Okay, that's great. So these are the arithmetic operators. As I've shown you, I can use them directly in the print statement, or I can perform them on literals, or I can store those literals in variables and I can do those too. Okay, and I can perform other operations over here too, like this. And here concepts like precedence and operators, hierarchy, and all of them come in. So which of the precedence is more here? Obviously this will be more, so it will be 25 plus 2, 27, but not 2 plus 2, 4, and then 5 power 4 will be done, because that's pretty much the basics of Bodmas rule and precedence in other programming languages. I think I don't need to discuss something not related to Python and which is common to all languages in this crash course. Okay, the result can be assigned to variables too. I've assigned the result to a variable and then I'm printing it, or I can print that basically over here, or I can perform them down literals too. Okay, so these are assignment operators, and these are arithmetic operators and assignment operators. We kept on using assignment operators from the starting, whenever we have used variables, even in here. So this is an assignment operator. Not equals to is not like, comparison between two things. Is LHS equals to RHS and all. It's not that. So a single equal to symbol over here is like we're assigning the RHS, or in some languages we call it the R value, to the L value. L value should be an identifier always, and R value should be a variable or a literal or anything. Okay. So yeah, so assignment operators, we've been using them. But there are other operators too, like we can do the arithmetic operators while we are assigning them. For example, I have x equals to 5. Okay, let me first comment these. Okay, no breakpoints, sorry. Yeah, so now if I want to assign, if I want to increment 5 by 1, I'll have to reassign it and add a plus 1 there, because first this the RHS will be evaluated. X plus 1 will be 5 plus 1, which will be 6, and 6 will then be assigned over here. And now if I print x, which I can pretty much do over there too, we'll get a 5 and then a 6, obviously, because before incrementing I am printing it's 5 and after incrementing it is 6. But there is a shorthand by using these operators over here for all the assignment operators we have discussed. Like we are doing just a plus over here. I can do a minus, or I can do a normal division, or a multiplication, or a modulus operator, or a double division, or even the exponential operation. I can do any one of them, but the shorthand is to use this syntax, where before the assignment operator I'll be writing the arithmetic operator that I want to use. Okay, if it is a minus, I use this star and all. So that does pretty much the same thing. There is nothing like post increment and pre-increment in Python. This is not possible in Python language. It is available in languages like C, C++, so don't try it. It is not a feature. Okay, so this is it with assignment operators and arithmetic operators. So is it only with strings? Are we confined and restricted to only use them in numbers and not in strings? No, we can use arithmetic operators on strings too. Okay, for example, from here on, we will be having these tasks and all. These are my favorite part of going through a series, because I want this as the output. This is the task that we'll have to solve now, and I'm having 3 variables which I'm going to uncomment. So these are the variables that are given to us, and I want this as the output. So I want to print it. And how do I print it? First, I'll have to print IM, and it should be in a single quote. And here comes escape sequences. Okay, I'll be discussing escape sequences too. Okay, see, I'm starting a single quote here, but I want a single quote as a part of a string, but it will consider that here it is completed, and after that it is not a string anymore. So it is not a variable or anything too. So how will Python render it? So we don't want this to end the string that we are passing in here. So to do that, we use a backslash, and that will mean that this is not the ending of the string. Okay, so if at all I don't use a backslash, the error will be risen. So if I use a backslash, anything after that backslash will not be considered as the same true self, but it will be considered as something, some other character. So here I am, and I can press Rahul and SriRam over here, but I'll have to concatenate it. This is where we are using string concatenation and interpolation, and we are using the arithmetic operators to add strings as we did while adding numbers. While in numbers, while we add them, we get, by the way, this can also be 5.4 into it, which in return will be 7.4. Yeah, 7.4 and all. We can add complex numbers too. Anything is possible. The real parts will be added and the complex parts will be added. I don't want to waste time on simple things. So yeah, but in strings, while we are doing the concatenations or the arithmetic operations, they'll be concatenated to a same string variable. Okay. So now, how am I going to use it? Obviously, since it's a variable, how do we take in variables in the print statement? We don't wrap them in quotes, right? Whatever is not a variable, we'll be wrapping them in quotes, and we'll be concatenating the variable in here, which will be replaced with Rahul. And between Rahul and SriRam, there should be a string space. So I concatenated a string space over there. Again, I'm concatenating the variable last name over here. And now I'll be concatenating a space and then end, because you see after Rahul SriRam there is a space and end. And again, I want to use I backslash :m and m. Here I'm having 19. Again, I'm using a space over there. I can use that, and age variable can be used. Okay, and now again I'm using for YRS, I'm not doing that space because there is no space between 19 and years. I'll press 19 years and space and old. Okay, there is a full stop too. That's great. Now all this will be printed to the console. Will it? No, you can't. Why? Yeah, so this is the problem with string concatenations. The issue is, while we are dealing with strings, here first name is a string, last name is a string, they will be just appended to the strings over here. It's quite common because there is nothing pretty much happening over here. But if at all we want to do it, age is an integer, right? If at all we want to concatenate an integer to strings, typecasting can be done, but concatenating will not do that by default, convert it into a string. So to convert age into a string, I'll have to wrap it with an str function. Obviously. So now I'll be converting the integer age into a string age. Okay. Now when I run this, I think I'll close this and run this, and I get, I'm Rahul SriRam and I'm 19 years old. Okay. It's cool, right? So this is how we use the plus arithmetic operator, this operator over here in the print statements. On also I can use these in these to assign to variables too. For example, if I have this as my str, okay, and I can print my str, and it gives the same result. Okay, I don't need to directly print all these. I can just concatenate all of them, and by the way, I can also do this. First, I can initialize it to that, and later on, I can use that concatenation operator or plus equals to, where we are assigning first name plus last name plus an IAM, all this to the initially existing thing. If at all I'm just using the assignment operator, it will be overridden. IAM will be overridden with first name and all. So if you run this, so you can't see all that because IAM will be overridden with Rahul SriRam and I'm 19 years old string. So if you don't want that to happen, if you want to concatenate that, I'll be using a plus over here, and now this will be the same as we did. So see in there. Okay, so that's how we use arithmetic operators, or and assignment operators, plus equals to and plus, mostly in string concatenations. So the third kind of operators are comparison operators. Okay, and how do I compare them? Now, for example, I can use them in print variables. Is 5 equal to 4? There are, I think, 1, 2, 3, 4, 5, 6 types of comparison operators. A double equals to is will check if LHS and R equals are equal, and if they are equal, this will decompose into, or this will be compressed and reduced into a true. And if at all these LHS and RHS is not equal, then it will be reduced into a false. Since these are not equals, it will be reduced into a false. And I think I'll have to comment these to be more clear. Now when I run this, you get a false. Obviously 5 and 4 are not equal. Okay, and the thing is, it's not just about printing. I can also assign them to variables. Okay, now this will be, you don't need to just write bool variable, and you just don't, we know this is false, but I just don't need to write as a false. Okay, I can do any complex expression on here, and all that will be compressed, and the final true or false will be stored in the bool variable. So yeah, that's a bool, and that data type is also a boolean variable. Okay, so this is how we check if two numbers are equal, and this is how we check if two numbers are not equal. Obviously these are not equal, so it will be a true. And if 5 is greater than equals to, see, don't confuse greater than and then equals to, or less than equals to, again less than and then equals to, you write it how you spell it. 5 is not less than equals to 4, so you get a false, but 5 is greater than equals to 4, so we'll get a true there, and less than and less will be strict, and this won't be considered. The equal to so will be considered. This is pretty mathematical, and I think you don't need to get too much deep into all this. Okay, so yeah. So the thing is, Boolean comparison operators forms the core part while we are getting into things like conditionals. Okay, in conditional, most of the times we'll be using comparison operators and identity operators, and at times membership operators. We'll be discussing membership operators later in this series, in this video at least, not in the series. And also the falsy values that I've discussed, those will be used, loops and all too. Now the fourth type of operators are logical operators. Okay, so what are logical operators? Again, let me get back to this same thing, and let me print this here, and let me uncomment this. Yes, that's great. I have this, right? I have 4 is less than equals to 5 is less than equals to 4, and it will be a false. And at the same time, if I want to check other condition too, for example 3 equals to 3, okay, I want to check this too, and I can just type in an AND in between them, and this will be considered as an expression, this will be considered as an expression, this will decompose into a boolean, this will be also reduced into a boolean. If only these both are equal, because it's AND operator, this and this are equal, only then it will be true. Either one of them is false, then the complete one will be false. This is like the same AND operator in other programming languages, like the double ampersand operator, but in Python we have A and D, the word itself. And when I run this, obviously you get a false, because this is false, this is true, but this is false, so it will be a false. In total it will be a false. If I type an OR over here, obviously either one of them can be true, and it will be considered as true. Okay, because that's OR. This is false, but since this is true, it will be considered as a true. If at all I want to use the NOT operator, what is NOT? What is boolean variable as of now? It is a false, and if I prepend it with this NOT over here, what it will do is it will invert it. So these are pretty much same to the logic gates and whatever we discuss in logic gates and all, AND gate, OR gate, NOT gate and all. It will convert the boolean logic to the opposite of it if we are using a NOT gate, and similar here. Even though it is false, since we are applying a NOT operator, in other languages the NOT operator will be denoted like this, and OR operator will be denoted like this, and AND operator will be denoted like this. Okay, that's it. So these are logical operators. Okay, we have identity operators. So what are identity operators? These are similar to double equals to and that not equals to, which we have seen in the comparison operators, the first two, but there is a small change in between them. I think I won't be getting into the discussion, the difference between double equals to and is, and not equals to and is not. By the way, is not is analogous to not equals. The not here is the same thing that we are using in the logical operators. So it will check if it is an is, and if at all that's a true, it will be getting a not out of it. Okay, we can check it that are for 5 and 4 equal, it is similar to double equals to operator, it will return a false. Isn't it true that 5 and 4 are equals? No, it is not true, so it will return a true over there. Yes, that's great. So it's similar to these. There is a small difference in between them that comes with data types. I think I can just do that. If at all I have a 5 over there, let's see what we get. Let me comment these. Why not keep you in suspense? get a false because the data type is different. Okay, but say I'm just doing it on the top of my head. I'm not prepared to do this at all. I get a true because this is a float, and this over here is integer, but it is typecasted because these are numbers, and this can be similarly typecasted into an integer. Okay, since the decimal value is 0, it will be typecasted and it's a true. But if you want to be so strict, and if you want the interpreter to check the data types too, and not only the values, and then I think we'll have to use the is operator. Is operator checks the data type too. Though the value of 5 and 5.0 technically is the same, it will still return a false. So this true is from here. It will still return a false because the data type here is an integer and here is false. So if at all you're familiar with JavaScript, it is like that triple equals to. Okay, in JavaScript the triple equals to will also check the data types, and only if the data types are equal and the values are equal, only then it will return a true. And this is the alternate operator to this. Okay, yes, that's pretty much it, guys. Those are assignment operators, and similar to these comparison operators, I can assign them to variables like this. Okay, we'll get the same output. It will be a boolean, it will be false. Though we are using is and all, we are not using the double equal and all, even then the data type will be a boolean. Okay, we are also having membership operators. I'm not going to discuss membership operators in this module. That needs a little introduction to data structures. So let's get into the next module. Alright then, so now we are done with operators, and let's get into conditionals. Okay, what are conditional statements? The if, elif and else keywords, they combinedly form conditional statements. So from here on, since we are comfortable with the basic syntax and all, we'll be getting into solving some tasks that are provided to us. The task is to write a program to find if a number is negative, 0 or positive. I'll also be demonstrating some scope in there. So we'll use the input function. We'll take a variable called num, which equals to an input, and as I told you, input will always take a string, so number will be a string. But to typecast a string into an integer, we can just wrap it with an integer. So now, though whatever we take is a string, it will be typecasted into an integer, and num will be storing an integer. Cool. So now we'll have to check if that number is 0 or positive or negative. So to check if that number is negative, or first let us check if it is 0. So to check if it's 0, we use the num double equals to 0, right? This will decompose into either a 0, either true or false, right? A boolean. Or I can also use num is 0. It is pretty much the same. So what does the if statement take? The if statement, there is nothing like the braces in there, and by the way, in Python we don't use curly braces and all. There is nothing of this sort in this language. We can use the braces there, but there is no need of doing that. So what we'll take is if number is 0, okay, and we'll put a colon there, and when I press enter, it will be tabbed by 4 spaces. So the number of spaces that is being indented that doesn't matter, but as long as we are in the same scope, I'll get into scope in the next moment. So as far as we are in the same scope, the number of indentations shouldn't change. Okay. As of now, my editor is using 4 spaces as the configured tab size, so that is why it is being indented to 4 spaces. That doesn't matter. Some people use 2. Google's Python formatter uses 2. I'm using autopip 8, so it will be using 4 by default. Okay, so if it is a 0, then we'll print 0, right? This condition, this if statement, this print statement is being embedded into this if conditional, and it is under this, it is scoped into this. Okay, so the scope of this is not global as of till now. In all the previous modules that we have done till now, the scope of every variable and every literal is global, because there is no the colon, and we are not indenting anything and all. Here the print statement will only be executed. So this is a condition, right? So these are known as conditionals. The if here is an if conditional, it will be only executed if this decomposes or if this reduces into a true. Okay. So now let me run this, and it's expecting a number. So let me input 0, and when I press enter, obviously this 0 will be printed because it's a true, and only when if it is true, it will come into this. okay? And when I don't enter a 0, for example I press a 4, and no output is being printed, because if it is not a 0, we are not printing anything else. So what should I do if it is not a 0? For that we have another keyword else, and again whatever comes under that scope, the multiple statements that are over here, to demonstrate scope, let me do this. I'll take an auto variable called output, and I'll take it as 0, and I'll print output. So that the assignment to the output variable and printing it to the console, both will happen only if number is 0. Okay, so this is what I meant by scope. And when these both are on the same scope, that means they both are under the same indentation after the same semicolon, after the same colon. So these are under the same scope. So as far as two where statements in Python are under the same scope, they should be indented in the same number of spaces. I can't be like, I'll indent it twice and I'll indent it 4 times. Okay, the indentation should be maintained as long as they are in the same scope. Okay, because indentation in Python for an extra space, it's a lot of hell, trust me. Now the output will be not a 0, and what I'll do, I'll print the output variable. Okay, now when I run it, if at all I give a 0, we'll get a 0 as printing, because here it will be this condition is satisfied, and it will no longer go into this else case, because it will go into the else case only when this is not true. Okay, so and now I'll go into this and I'll give 5, and it will give not a 0, obviously, because 5 is not this. But it wanted us to check if, so what I meant before coming to the program, what I meant by same indentation levels, as far as these both are under the same scope, they should have the same indentation level, which is 4 spaces. And as far as these both are under the same scope, these should be under the same indentation level, and minimum should be 1, because if at all they are in the same indentation level as else, then it will raise an error, because after there's a colon there should be at least 1 statement. So it can be 1 space 2 or 2, 3, 4, 9, anything, but these both should have the same indentation. Okay, it shouldn't vary from all the other things that are being in here. So this will run 2. Okay, so what did I do? Yeah, this will run 2. Okay, I'll give 6 and it will give not a 0. Okay, but these both should be in the same indentation level. I don't like doing it. I just follow the 4 indentation level for everything I do. It doesn't matter, but they should be the same. So yeah, now getting into the program, we have if number is greater than 0, for example, greater than 0, I won't be taking it and that, and why do you have to complicate things? Let me just do it that way. And I'll print greater than 0, less than 0. Okay, is it? Yep. So now I go there, I print something greater than 0, which is 3, and I get greater than 0. That's cool. And when I run it again, -4, and I get a less than 0, that's fine. But what will happen if I give a 0? Obviously, since it is not, 0 is not greater than 0, because 0 is greater than equals to 0, or 0 is equals to 0, but it is not greater than 0, it will go into the else case and it will print less than 0, which is not true, right? There is a bug in our program. Even though we are giving 0 as an input, it is giving less than 0. Actually, we want 0 as the output, capital Z, 0 as the output. So for that to happen, we have another statement where after the if and before else, we can write multiple if statements, and all the conditions inside if and all the elifs that are present will be checked. If none of them are true, only then the else case will be executed, or if either of them is true, then either of them will be executed. Okay, so how do I do that? Here I'll come into elif, and for elif, unlike for else, we'll have a condition here. For else, we don't need a condition, because if this condition is there for an if statement, that means the opposite of that will be the true for the else statements, and so there is not much to write after else. But in elif, we need to write. So if number is less than 0, then I want to do that, right? That's great. Okay, but else then I just want to print a 0, right? If the number is greater than 0, we print greater than 0. If the number is less than 0, we print less than 0. And the only case which doesn't satisfy with these both will be equal to 0, and hence I don't need to again write. I can also write elif here, and an else statement is not a must. Okay, I don't need to write number equals to 0. I don't need to write an else statement here. Okay, so elif number equals to 0, then it will be like print 0. Okay, an else statement is not a must and should, but what is the very need to write a condition and all? Okay, so I can just be like else and print 0. So now when I run this program, if it all I give a 0, oops, not there, here, if it all I give a 0, there will be a 0. Okay, and greater than 0 will give greater than 0, and something less than 0 will give less than 0. Okay, so yeah, we wrote a program to find a number if it is negative, 0 or positive, and have also demonstrated scope. These are conditionals, and the membership operators, as I've discussed, I'll be discussing these in the data structures thing, because you need that is a prerequisite to understand this. And obviously in the following videos we'll be discussing global, non-local and LGB rule, and also these are the normal conditionals, and there is also ternary conditionals which I won't be discussing now. If you're too eager, you can watch my previous video, lead code problems, or solving 2 lead code problems, where I've used ternary conditionals. And also we have dealt with conditional operators, right? We can chain them. Chaining is possible in Python for conditional operators that I have not discussed. I'll be discussing in the previous videos. So that is it for this module, guys. I'll end this here. Okay, now we're getting into the biggest module, which is data structures or iterables in Python. So what is an iteration? Iteration is something which we can do in loops, okay, which we can do continuously. So a data structure or something, an entity on which we are able to iterate on, okay, in which we are able to loop through, is known as an iterable. Okay, we are able to iterate on them, so they are known as iterables. There are 4 basic data structures or iterables in Python. There are many others too, but these 4 are very accessibly used and the most common. So the first one is lists. Okay, data structures, 7th module will be quite interactive, where I'll be asking questions and I'll be stating reasons. Okay, and there will be some tasks too. For example, the list data structure or the list iterable is ordered and it is mutable, and duplicates are allowed. Okay, for example, a list of entities will be taken in like this, in squiggles or in square brackets. The data type we need not mention, it will be of the type list. There is a default type called list. It is like an array in other programming languages, but arrays can be of the similar data type, like an array of integers or array of characters, which is a string in some languages, or array of strings and array of floats, and that is quite possible in other languages. But in Python, since it's dynamically typed, a list can consist of variable data types. So 1 and then a float. This is an integer, a float, a complex, a boolean, a string, and again an integer. Okay, a 1 and a 1. So a duplicate is there, and a duplicate is allowed in here. Okay, there is nothing like even if I enter 2 or how many number of same valued things in there, only one of them will be executed. No, nothing of that sort is there. How many we push into the list, all of them will be a different entity. Okay, so mutable, come into that. So yeah, let us answer these 3 questions. Before doing that, let me check if I have any print statements. No, I don't. So let me print this. Let me run this program. You see that 1, 5, 3 plus 3j and true, Johnny and 1. All of them are printed. Like whenever I print a list directly to the console, this is how they're going to print. However, we are assigning it in the same form they are printed. Okay, we can use the len function not only on strings as I've shown you, but only on also all the 4 data structures that are available. So the length of this will be 1, 2, 3, 4, 5 and 6. So the length of this will be string, and the type will be of list. Okay, it is similar to an array, but it is not an array. So yeah, let's ask questions and let's answer them. I told ordered. So how is it ordered? Because elements can be accessed by indices. Okay, that's the reason. So what do I mean by elements can be accessed by indices? Index based accessing of elements is not quite new to the Python programming language. In many languages, arrays are index based. Okay, there are some other entities too, where we'll be having other entities to other ways to count and order elements. Okay, for example, hash tables will have something called as a hash function. Okay, and linked list will have something called as the links, and it is not random, it is just having a pointer to the next pointer in all of them. And in arrays it is index wise. Okay, there is nothing like what is the next element of the array, is the data in that storing it, the pointer to that. No, nothing of that sort. Purely based on the indices it will be done. So similarly we'll be applying that over here in list too. So what happens in a list, it can be accessed by the indices. For example, if I want to print my list like that, you have seen what comes there, but I can access it by using the squiggles again. And when I press 0, the first element, because 0 based indexing is followed in lists. So when I press my list of 0, the 0th element, which is 1, will be printed to the console. Okay, see that 1 is being printed to the console. And now when I take, for example, 2, which is the complex number. Okay, and now when I run that, I get the complex number in there. Okay, let me just comment this to avoid confusion. Yeah, so it is ordered because this is ordered on the basis of indexes. Okay, this is the first element because the index is 0. This is the last element, and all these available to us, and we are able to access elements on the basis of indices or index. So that is why it is ordered. Okay, there is nothing like a random thing. We can quite blindly tell that the first element is this and the second element is this. So we are pretty sure that these are in an order and on how they are inserted, right? And what is mutable and immutable? Actually, mutability is something that reassignment and changing the subparts of it, all of these come under mutability. So what is something is called mutable if reassignment is possible. Okay, and something is called immutable if once we initialize something and we are not able to change the object of it, the data type of it, or the values of it. Okay, so that is known as immutable. So there are some immutable data structures too, but list is immutable. So how is it mutable? Let us ask a question, how is it mutable? And the answer is because assigning is possible. Okay, we have just seen accessing an element using index, but we can also assign my list of 2 to be a string. Here a complex should be there. Okay, initially a complex should have been there, but now I'm changing it to a string. And now when I print my list, okay, and when I run that, see, it's the same. Instead of 3 plus 3j, we're getting here a complex should have been there, and true, Johnny and 1, it's the same. Okay, so assigning a single element or single entity in the whole list is also possible. So we're able to change values of it, or we are able to mutate the values of them. So that is why assigning is possible, and hence it is mutable data structure. Also, that is not the only reason. Even adding elements, like improving the length of it, or removing elements like decreasing the length of it, is also possible. Okay, so because adding elements is possible, and there are 2 methods to do that. Okay, I'm not going to do that. Okay, and I'll comment this too. How do I insert at the last? Okay, we use the append method on this data structure. For example, this is my list, right? So my list dot append. If I press append, and whatever I pass in here will be added to the end of this list after here. Okay, like index 0, 1, 2, 3, 4, 5, and at the index 6 that will be coming. So whenever I access my list of 6, the appended element will be printed to the console. Okay, for example, I want to print the number 8, and oops, now when I print my list and now I run that, see, 8 is being appended at the last. Okay, so append, it takes something which needs to be appended. Append is like adding at the end, that is known as append. It is an English term and nothing related to programming in that. It is quite understandable. And what is the other method? Insert do. Insert does the same thing, but instead of doing at the last index, we can pass in 2 parameters. And one is of course the what we want to pass in. Okay, first thing is the index. For example, I want to change the first thing. Okay, first element of that, and I want to a true or a none. Why not a none? Even a none is a data type, and that is also possible. Okay, and I print my list again. Okay, now I do that. See, first when I just appended 8, it is being appended there. But now instead of append, if I had done append of none, after 8 none would have come, but since I'm specifying an index there, at that index the past value is being added to the list. Okay, so that is the difference between append and insert methods. Both are used to increase the length and change values of the list, but we're able to change, reassign it, not actually reassigning it, but incrementing the length, or creating more space for this list and all. So it is mutable. Okay, there's nothing like once we have declared it this way, we can't do anything on this, and we can't increase it or decrease it or change some values in it. That is called as immutable. Okay, so since we are able to do all this is mutable. Okay, so it's pretty much it. There is nothing much to understand in adding and mutability and immutability. Now getting into removing elements, that is also possible. We have 3 methods over here. What does the remove method do? The remove method just removes by value. So now if I take mylist.remove, and if you want to see what that does, remove first occurrence of value. Okay, for example, what I mean by this is we are having duplicates, right? It will come from the 0th index and it will keep on going from left to right, or 0 to the len-1 index. Whenever we seize the parameter that we are passing, in this case 1, at the first time, that will be discarded. Okay, if for example the first element is 5.1, and let me put a 1 over here and none there. Okay, like see 1, none true, Johnny, and again a 1. So now this one will be regarded because that is the first occurrence of this. Okay, now when I want to print my list, and see that there is no 1 over here. Okay, that is the first occurrence is being removed from that. Okay, so that is where we use the remove method. We can also use pop. So what is pop? Similarly to my list, I can use pop. Pop takes in a parameter which is optional parameter. If I want to send it, the element at that index will be removed. If I'm not sending anything, it will be defaulted to the last index. So let us see that. I'll comment that and take in this, copy, paste. What is the last element? It is this one. So 1 will be discarded if I now print it. Yes, the 1 is being discarded because I'm not passing anything over here. But if at all I pass 0 over here, now the first index will be taken out, which will be 5.5, and this you see indices will be reordered, by the way, if you are appending elements and if you are removing elements. Now since I did this, there is nothing like after the index thing, for example 0, 1, 2, 3, 4, 5 and 6. If at all I did pop without an index being specified, then only till index 5 it is valid. Okay, the 6th index is not possible. If at all I try to access it, and runtime error will be raised. I'll get into errors later. So when I run this, the first thing is being discarded, which is a 5.5, and from the next on, this is the 0th index, 1st, 2nd, 3rd, 4th and 5th. Okay. We can also use the clear method. Clear method is to run a pop the length number of times. It's nothing but deleting the whole list, but not deleting it from the memory, but making the list empty. Okay, there is a difference between, see, I can also initialize my list to empty list. Okay, my list equals to an empty list. This is how we do it, and when I print my list there, I get an empty list from there, and after clearing it, we'll get it to here. Okay, my list. But so that is one of the reasons. Removing elements is also one of the reasons. I won't be clearing this. Removing elements is possible. That is why it is mutable. So the justification is being done for ordered, and there is another justification for mutable, which is completely a reassignment of a new list. See, this list is completely a new list. Even we did it here from an empty list, we reassigned my list to another completely new list, and again we are reassigning it to another new my list. And when I print this new my list, this will be printed and not the old one. So within the same using the same variable name or within the same object, we're able to change the object that it is pointing towards. So obviously it is mutable. Okay, so I think the justification is being done for how is it ordered and how is it mutable. So the questions are being answered. There is a note, how can I use the del keyword? So the del keyword in Python is used to erase memory. Okay, for example, I use del and my list of 1. Okay, what is the my list of 1 now? Stack is 0 and q is my list of 1. And now when I print my list, now when I run that, the q is being taken out, and it is pretty much the same as running, pretty much the same as doing, where am I? Yeah, here, my list.pop of 1. Okay, instead of this has got no effect if you are specifying an index over here. Okay, it's just that the element at that index is being taken out from the memory, and the remaining are just rotated by a single thing. So the tree becomes the 1th index, and graph becomes the second index and all. Okay, but we can also erase the whole list. Okay, erase the whole list from the memory itself. That is also possible by using the del keyword, and I need to just do it that way. And now if I try to print my list, this is not the same like clear. Okay, if I'm not specifying anything, it doesn't mean that it will empty all the list and leave me with an empty list. Okay, this is not like that. What happens here is an error will be raised because name error, my list is not defined, because it is completely taken out from the memory, and it is like no longer from line number 48 the interpreter doesn't know any variable which is having a name called my list. So whenever we are trying to print it to the console, it will quite overwhelmed from where the hell did this my list variable come from. I don't even know anything about it. So that is why it will raise an error called name error. Okay, now we can handle such kind of errors again using try catch blocks. Again, not only the most common error is not only this thing, but for example 0, 1, 2, 3, 4, 5, 6 and 7, we are having an indices till 7. If I try to take this 8th index, which is not existent, which is non-existing, if I try to do that, I'll get an index error. Okay, this is also quite common in ordered data structures like lists. Okay, so yeah, that is pretty much it to discuss about lists, guys. So there are some other concepts too, like we are accessing on the based upon indices, right? For example, my list of 2 or my list of 8 and all. There is also a concept called negative indexing, where we can access elements from the back, okay, by using negative indexes. That is also pretty much possible. That is not quite complex to understand, but I don't think I'll be discussing it now, because there will be a special video coming on lists and slicing and all. So we can join to lists, and there is also I've discussed many methods here, clear and pop, remove, append, insert and all. There are also other methods like copying, index, reverse, sort, extend. I'll be discussing all of these in great detail. List comprehensions come in really very handy. This is like one of the coolest features of Python. If you want to know more about this, there will be a video coming soon, but if you're too eager, I've also already made that video, as if I kept on telling you from the starting of this video. I have that I've used this comprehensions concept in that video, and even slicing. I've used slicing to reverse the string and all. Okay, and deep copying and shallow copying is a complex concept. Like, what is the difference between copying and how mutable and immutable data structures play a vital role while trying to copy these, and there are some modules which enable us to do deep and shallow copying, and what are references and all. So yeah, this will be a very interesting thing to discuss in lists, and not only in lists, but this is pretty much the same with strings and tuples and sets and all. So yeah, we're done with the first data structure in our 7th module, which is data structures. Now we'll go to tuples. Great. What are tuples? Same like lists, they are ordered too. Like, they're ordered, but they're immutable. Okay, like once we assign them here, we cannot reassign or change or increase the length and append a value, or insert at a specific position, or decrease them or delete a specific value and all. That is not possible. Okay, and similar to lists, even duplicates are allowed, 1 and 1. That is quite possible. Okay, let me just comment these to. Is there anything else? No. Okay, now let me run this, and what you see there is a tuple. tuple, unlike lists we use the squiggles or the square brackets, and in the tuples we use the normal parentheses. Are these called parentheses? Why do you keep confusing between all these flower braces, I call them? There is a specific terminology. I think I'll discuss them in the next video. I'll learn and I'll teach you too. So yeah, in this circular braces, or however you spell them, we use these to define tuples. Okay. Now, yeah, however we are assigning it to the mytuple variable, that is how the print function will be printing it. Okay. There's a special variable called tuple. Again, like lists, they don't need all of them. They don't need to be the same data types. Okay. They can be of different data types too. Now, the length can be applied on this too. So whenever I pass a tuple to the length function, it will return the length of it, and the type will be a tuple. Okay, cool, great. Yeah. So now, how is it ordered? The questions I keep asking these questions on each data structure, and I'll be stating the reasons in the form of code. Okay, so I told it is ordered, right? How is it ordered? Because elements can be accessed by indices. And how did I prove that? I used a print statement, I used a mytuple, and I put in there. Okay, and now when I print this, the first 0th index element is 1, and that is being printed. So this is 0th index 1, this is first index. So we can see that this is ordered. Okay, this is a structured kind of thing. So it is indexed and it is ordered. So that is why it is ordered data structure, and it is being justified. And why did I tell, unlike lists, this is immutable? This is immutable because assigning and adding elements. I've discussed assigning elements and also adding elements in the previous thing. That isn't possible. Okay, in lists, in tuples, that isn't possible. There are no special methods like append or extend, or what else did I use there? Insert and adding elements. And same comes to removing elements. There is nothing like pop or remove, and there are no methods for removing things. Okay, I can't be like my tuple of 0 equals to some variable like this. Okay, that isn't possible. Okay, because my tuple is a tuple and it is immutable. And now when I try to print my tuple, I'll get an error because tuple object does not support item assignment. Okay, because it is immutable, assignment is not possible. And similarly for adding to, there are no methods involved. Okay, but if at all it is a must. See, these 3 lines of code here, there is no point in doing it when we know we are using an immutable data structure. The whole point in using an immutable data structure is to maintain that immutability, right? If you want to append something, then why not use a list? Okay, that is the point to be made. So tuples are only made and should be used only when you're pretty sure that once you initialize them, you're not going to reassign or append things and insert things and delete things and all these kinds of stuff. You won't be doing them. Only then you'll have to use tuples. Else, I think you should stick with lists, because there is no point in converting them back to lists, doing the operations that we'll be able to do on lists, and again converting back to tuples. Okay. So here, what am I doing? I'm having a mytuple. Okay. I'm converting into a list using the list constructor. As I've told you, for int is a constructor and it is also a data type, because int is a class and int also comes in as a constructor because the constructor name will be the same as the class name. We can use that to type convert between tuples to a list. Now my tuple will be a list because I'm using a list over here. And now since my tuple is a list, I can use the append function over here, and I can use the Python and I can append Python here. Not only append, since I've converted into a list, I can change the value at something, or I can also use the insert function. And I'm just doing this an example. And again, I'll convert back that tuple into a tuple by using the tuple constructor, and I'll assign it back to the same variable. So now, when I print my tuple, what I get is something with Python is added, which initially isn't there here, and this quite contradicts the very point in using tuples. Okay, we don't want to do this, and if at all we want to do this, then why do you want to convert it to a list, do some operations and do it in the backward? Okay, why don't you just use a list? Okay, so don't do this, but I just mentioned it because it is possible. Similar to removing elements, it is quite similar. You can't just be like, there are no methods in tuples to remove operate on tuples, but if you want to remove or use the del operator or pop and clear things and all, you can convert it into a list, remove that Python thing over here, and you can do that. Okay. For example, I should have discussed this in list, but this is an opportunity to discuss in tuples too, because I've converted my tuple into a list now. This is a list, and I'm applying the remove of a value which is not there in the list, because I've commented this, because and here the only things that are available are here in this, and we are trying to remove something that is not present in the tuple. Okay. Now when I run this, I get an error, value list, X is not in the list. Okay. Now value error can again be cleared using try except blocks and exception handling. Okay. So yeah, if at all there was this thing, let me uncomment that and comment only this. And now when I run that, what happened? Yeah, oh sorry, I forgot the print statement of my tuple. Now when I run that, see Python added here, and now again I deleted it using the remove method. It's pretty much it. So yeah, so this is why, since assigning, adding or appending and deleting is not possible, it is an immutable data structure. So this question is also being justified. Okay, I've also already shown you duplicates are allowed. Now there are some notes, but assigning single elements is not possible, but tuple can be pointed to a completely new tuple. This is possible. Okay, now if I print my tuple, go there, I get the stack Q3 in the form of a tuple instead of the first thing. Okay, because reassigning is possible, like the complete data structure can be reassigned to something else, but parts of it can't be done. Okay, so yeah, to erase from the memory, as we have discussed earlier, you can use the del keyword. Let us check what will happen if I erase based on indices. Okay, for example, now my tuple is stack, right? The 0th index is, and when I did do that, I get a type error because item deletion is not possible. A single element, if it is being deleted, that contradicts the statement that it is immutable, so it is not possible. But it can be completely taken out from the memory itself, and when I print my tuple and I run it, my tuple is not there, obviously, because I've taken it out from the memory. Okay, so yeah, so that is pretty much it for tuples, guys. So it is an immutable data structure, unlike lists. And if you know that there will be changes in your data structure, there will be elements to be added in the future or removed in the future or reassign some values and all, it's better to use lists. But if you want to follow some immutable data structures, and if you are into functional programming and things of that sort, where the whole point of functional programming is based on immutability, and that is the core concept behind it. So we can stick with tuples. Okay. It is quite tough to initialize an element with a tuple with one element. Okay, it is not as easy as in initializing with a one element list. Okay, I'll be discussing it and what is wrong in initializing a tuple with one element and all in the later videos. Similarly, negative indexing is also possible in tuples as it is possible in lists. Okay, we can join tuples, two tuples. We have seen the extend and copy methods in the previous for lists, and for tuples too we can do that. And the same deep copying and shallow copying I'll be discussing here. There are the sort and the index methods too. I have not discussed them in here. The only methods available for tuples are index and sort. There is no other method available in the tuple API of Python. And then comes tuple slicing and tuple comprehensions. As I've mentioned, they are similar to list slicing and list comprehensions. And there is a special data structure called named tuples. Okay, so what are named tuples and how they differ from the normal tuples and all? What is the difference and what are the benefits of using it and when should we use this? All this we'll be discussing in the later videos. Okay, so stay tuned. I'm making this crash course first because in the later videos we get deeper and deeper into the language, and we'll be using all these concepts. You need a basic knowledge of all these concepts. Like, you can't just be like, I'll learn input and output to the fullest, because while dealing with input and output, at times you'll have to use the map function, at times you'll have to use the list comprehensions, okay, and at times you'll have to use the for loops and range functions and all of them. So to understand all of that, you'll have to first know what is the input function and what is a for loop and all. So this is the very reason behind doing the first crash course, and then again revisiting the topics and getting into great detail for each data structure and for each minute concept. Okay, now let's get into sets. Sets are unordered, unlike lists and tuples, but these are mutable, okay, which is like lists and unlike tuples, but duplicates are not allowed, okay. Duplicates are not allowed by object and not by value, okay. I'll tell you what that means. Let us see. Are there anything? Yeah, clear. I think I don't want that to happen already. Sets are like the same things which we see in our mathematics and union set operations, union operation, symmetric difference and difference operations and intersections and all those will be possible on these sets. These are pretty much used for solving mathematical problems. We'll get into that later. Now when I run this, the class is set, the data type is set. We can pass it to a length function and it will return the length of it. You see, though I'm passing 1, 5.5, a complex number, again a 1, Johnny, and again a 5.5, only the first occurrences are being saved, and if the duplicates are being revisited again, they are not being appended to the set, okay. A set, we use the curly braces, okay. For tuple, we use that circular braces thing, the parenthesis or whatever you call that. And for lists, we use the squiggles or the block braces. And here we use the curly braces, okay. Only the non-duplicates and non-identical things are being sent into the list, into the set. And only the length of that will be taken, though we are passing 6 elements in here, but we are still getting the length as 4 because those will be not considered. Because in sets too, while performing union operations and all, if you are pretty much aware of sets in mathematics and all, we have sets in mathematics and we have set A and set B, and while performing union operations, we get, for example, all the things that are present in both set A and in set B too. But if at all there are some things common between them, if at all there is some, if at all the intersection set is not null, then even then we don't get multiple values, right? For example, 1 2 3 is the first set and 1 2 4 is the second set. The union will be 1 2 3 4 and not 1 2 3 and 1 2 3 4, right? 1 and 2 won't be repeated again. So the pretty much same concept will be applied here too. Okay, let me comment that out. And I told unordered. How is it unordered? You know the drill. I'll just do the same thing. Because elements can't be accessed by indices since there isn't any indexing, okay? For example, if you have seen this, there's a 1 over here, and if at all it is going from left to right or any pattern, if at all it is following any pattern, since this is not identical to 1, 5.5 should be the second thing over here, and 3 plus 3j should be the third thing, and like that, and then should come Johnny. But here it kept changing, right? Even though these all are not identical, 5.5 is being sent to the last, and Johnny is being sent to the second, and it is not the same way how we are doing it. So it is very random and it's very unordered. We are not having any specific index based accessing elements and all of that is not possible. Okay. So that is why it is unordered. Okay. So since that is not possible and it is not allowed, we can't do that. And I told it is mutable. And how is it mutable? Because there are many reasons that it is mutable. The first thing is we can add elements to it. Okay. So I'm having my set dot add method. Add takes in a value and it adds to the 10. Let me take a string called Rahul. Okay, and now when I print my set and when I run this, see Rahul is being added. I don't know where because it's unordered. I can't guarantee you that it gave inserted only here. By the way, you see Johnny is in the first position there. You expect it to be in the same position, and this gets appended in the middle and this gets moved. No, but nothing of that sort happens over here. It completely changes. Okay, so it's very random and it's very an unordered data structure, but it is mutable because we are able to add on it. Okay, you can also use the update method where it can be like my set dot update, and update is like not adding a single element. Here we are adding a single element. We can also add a list of elements or a tuple of elements or a set of elements. Anything is possible. For example, passing a list of elements like x, variable x, not variable, character x, character y, and by the way, there are not characters, there are actually strings because there is no special data type like characters in Python. Even the single character length, single quotes or double quotes, whatever you use, it is considered as a string only. Okay. Now when I do that, I am passing a list over here. And you see, the list is not being taken in as a thing. Okay, each element in that list is taken as a unique element that is being appended to that. But if at all I use the same list here in the add method, then the whole list will be taken as a single identity or an entity, and it will be passed as a parameter to the add method. Removing elements is also possible, as we have seen here. Remove method can be used to remove a value, but it will raise an exception if the element doesn't exist. Okay, like for example, I'm having my set dot remove, and for example, I want to remove the character X that is present, right? That is present in the set. Let me just take this out. Okay, I don't need that Rahul thing in my set. Now when I run this, see that X is being discarded. Okay, remaining all also same, but this will raise an exception if it is not present. For example, a string of value 1 to 3. This is not present, and it will give the error called key error. Okay, 1 to 3. This is not present in the set, so it will raise an error. So if you don't want to raise an error though the element is not present, and you don't want to do anything if the element is not present, we can use the analogous method called discard. Okay, what discard does is it will do the same thing, but instead of raising an error, it will do nothing. That's all. If the element is there, it will remove it. If it is not there, it doesn't raise an error. Okay, so to get until this point in the program, I'll have to comment this, because if there is an error over here, the execution will stop there, and all the statements after that line won't be able to execute, or won't be executed, and the output won't be shown in the terminal. So that is the very basic reason why we do exception handling. Now when I run that, see, there is no change. It's just being printed. But if at all I pass X over there, X will be discarded. Okay, that's pretty much it, guys. Now I can also use the pop method to remove the last element, and you can see the pop method doesn't take any parameters. Okay, it won't take any parameters. It will just remove the last element that is being present in the set. But this is random, right? We don't know, we always don't know what is the last element in the set and all. It keeps changing based on the previous state of the set and all. So it is very much less used. People don't regularly use this thing. So here, see, this is what I was discussing about. I have a 1 Johnny 5.5 Z 3 plus 3J and Y over here. So what do we expect? The last element is Y, right? So we expect that to be taken out from the pop. But no, that doesn't happen. Okay, the pop will take out something. It will remove something very random. Yeah, by the way, it will return something. I'll get into that. It will take something very random, and it will return what it is being removed from it. So if at all you want to show what that is, I can assign it to a variable there, and with that I can also print an X there. When I run that, I see 1. Okay, you see 1 is being taken out from here. Okay, while I was running this in the previous thing, Y was being removed, not 1, right? Yeah, so that's it. That's a drawback of pop. We are not sure which element will be taken out, but this returns which element is being taken out, and we can print it to the console. Okay, that is the advantage of using it. I can also clear it, right? I can just be like clear the set and empty the set. So it will just return the set constructor. It won't return that empty braces we have seen in tuples and lists, because the same braces will be used for dictionaries too. For dictionaries, empty dictionaries will be that, but for set, it will return a set constructor with no parameters in there. Okay, that is the difference between sets and dictionaries. We'll be getting into dictionaries in the next few seconds. Okay, so the clear is this thing. So yeah, so this is why it is mutable. We can add elements using add method, update method. We can remove elements using remove, discard, and pop, and clear, right? We can point to a new set too, like this. Okay, let me take that out. Again, take that out. Yeah, cool. We can point the set to a new thing too, like this, stack, queue, and all. Initially it was this, but now it is not that anymore. Now when I run this, if at all I run that, print my set over here. When I run that, I get set graph, and see that again it is very random and unordered. There is nothing like stack queue, and that is the thing being shown here, right? It is random. So it can be directly deleted from the memory too by using the del keyword. Okay, we can use the my set, and when I try to print my set, obviously it will raise an error because name error, my set is not defined because we've taken it out from the memory. It is not the same as clear. I have discussed this earlier. Wow, that rhymes. Okay, now as I've told you, not only union, there are also other methods like intersection difference and symmetric difference also. We'll be discussing them. I'll be solving some set related competitive programming problems using the sets data structure of Python. And also I've just used update over here, and I used a list. I can also use a tuple there. Oops. A tuple there, and it works the same. Okay, there is no much difference there. It will just be like this, and when I print it, not over here, before that it will be executed. You see that z, x and y, though I'm adding as a tuple, they are being added. Okay, I can also add them as set 2, that doesn't matter. Okay, similar to that update method, we have intersection update, difference update, and symmetric difference update, which will be like, update is like the union and update, right? We are doing the union operation here as we are updating it. In the same way, we can also do the intersection update and difference update and symmetric difference update too. I'll be discussing them in great detail. There are some boolean checking values too, like are these two sets disjoint, like set 1 dot parameter of set 2. Those two sets will be checked if they are disjoint, or those two checks will be set if this is a subset of this or if this is a superset of this. Okay, so these will be written in booleans and all. Similarly, there is a method called copy, and I'll be again discussing deep and shallow copying and references and all of this. And if you see, I've not mentioned any booleans over here. Okay, because there is a great mystery behind booleans to be used in sets. If at all I try to print that, the very first thing, you won't see that. Though true is not being repeated anywhere, it is not being included in the very first thing. Why? Because what is wrong with having booleans in our sets? There is a theory behind it, and it's quite a long one to discuss and all. So I'll be discussing them later in this video. So I'll also, similar to tuple and list comprehensions, I'll be going through set comprehensions. But there is something called other data structures similar to tuples and named tuples. There are called sets and frozen sets. So what are frozen sets, and how can we use frozen sets? What are the concepts of immutability and mutability that comes under frozen sets and all. So we'll be going through them. Okay, so yeah, cool. Now we're done with sets. We'll get into dictionaries. Dictionaries are not similar to sets, lists and tuples. They are completely different data structure. Okay, these are unordered too, but they're indexed. See, that is quite a tricky statement there. It is unordered, but it is indexed. It is mutable, and duplicates are not allowed. Okay, duplicates are not allowed. I'll show you what that doesn't mean. Again, there is a trick in there. So if you know Java, and if you know hash maps and maps, and in C++, unordered map and map, it is similar to that. Dictionaries are similar to that. So dictionaries will be in the form of key value pairs. Okay, it will be similar to a list, similar to a set. Curly braces will be there, but inside that set we'll be having the keys as strings. Okay, you see the single quotes, the list strings. All the keys are taken as strings, and the values to them can be anything. Okay, the values, these are the strings on the RHS of the colon, and to the LHS of the colon we have integers or floats or strings or complex. We can also assign lists, tuples, sets and dictionaries. We can assign functions and lambdas too. We can assign classes and objects. So everything is possible in dictionaries. Okay, so yeah, we can also write a mini oops using dictionaries, but it is not much practiced. There also, while declaring dictionaries of this sort, we'll have to separate each key value pair using a comma, not a semicolon. There are no semicolons in Python. I hardly saw people using semicolons in Python. At times we can use them, but we separate them using this commas only. Okay, for the last thing, we shouldn't include a comma. Okay, else I think that will raise an error. Will that? I don't know. I'll have to check that out. Okay, sorry. Yeah. Okay. Now, are there any things? No. Let me run this. See that? I have two lists, hobbies and favorite food. Forget about hobbies as of now. I'm having favorite food, ice creams, omelets, Coke and pizza. Okay. My first name is Rahul. My last name is SriRam. age is 19, and again age is 20. Okay, I'll discuss this. And the favorite food is being you pointed to a list called favorite food, which is declared here. Okay, now it will be shown in the console of this sort. Okay, see that first name Rahul, last name SriRam, age 20, favorite food, and this list. The length, again I can pass this through the length function and I'll get the length of this. It is 1, 2, 3, 4 and 5, but we're getting 4. How? And by the way, the latest value of the age or the repeated key is being assigned. Okay, that is what I meant here. Key duplicates are not allowed. Overwrites to the latest one. Even though we are having 19, but the latest updation of the age key is in age of 20, because that is coming after that piece of code. So that will be overridden, and this will be completely taken out from the list. So 1, 2 and 3, 4, only 4 elements are in there, and it comes under the class called dect. Okay, great, cool. So the type will be a dect. I just don't need these 3 statements. How is it unordered? I told these are unordered, right? Because elements can't be accessed by numeric indices. It is unordered because how do you measure an order in things? We can measure an order in things only by using numbers, right? Only numerical indices, 0 to 1, or there should be some increasing or decreasing order between the indexes, and only then you can say that it is ordered. But if the only way to access the values in a dictionary are by using the keys and not the indices, then we can't be like it is ordered, right? Hence it is unordered. So, but we can access elements in a dictionary using the same square braces syntax as in lists and tuples, but it is not possible to do it based on indices, but we can do it on the basis of these keys. Okay, so my dect of see that first name. Okay, when I try to print that to console, I get Rahul. Okay, so we can access in the same way, but instead of passing the index over here, I'll be passing the key name over here, and the respective value of that will be given to us. Okay, and we can use that, or a similar syntax to this, or not the similar syntax, but the similar thing can also be done using the .get method of dictionaries. Okay, so myDict.get, this method will take a key, okay, and it will return the value that corresponds to that key. Okay, now when I print that, I can get Rahul. Okay, it's pretty much same. We mostly use this for assignments, not while printing things. For printing to the console, like if at all the main focus is to print to the console, we don't use this, but we use this. But okay, so this comes under unordered but indexed. It is indexed based upon keys, but not based upon indices, numerical indices. Okay, I told mutable, so let's ask the question: how is it mutable? How is it mutable? Because assigning a value to a key is possible, as I told you. My dict of first name, I can assign another variable to that. It can be like ESC, which is the name of the channel, by the way. I can print it to the console, my dict. Do that, you see, first name is now TSC and the last name is SriRam. Okay, initially it was different. And adding pairs is also possible. There is no specific method for adding pairs in dictionaries. We just do it this way. For example, I want to add a boolean. Okay, we'll take Ismail over here, and sorry, Ismail is a boolean, and it's true because I'm a guy. And now when I run that, obviously I can't see that because after assigning it, I'm not printing it to the console. When I print that, I get Ismail equals to true, added as appended to the dictionary. Okay, initially there is no that key value pair. Now that a new pair is being added. Okay, so if at all I involve a key that is already existing, that comes under reassignment. If at all I introduce a new key, that comes under adding a pair. Okay, so there's the difference between these two. Okay, and this is one of the reasons for why a dictionary is mutable. Again, there are other reasons too, like removing is also possible. We have 3 methods. We can use the pop method. Okay, mydict.pop, and method to remove by key. We can send in ismail over here, and I can be like print my dict. When I do that, again here there was no ismail and true property there. It is being, the key value pair is being added. Again I'm deleting by the name of the key and it is being deleted. That's all. It's quite simple. Okay, but what does the pop item thing do? Okay, when I comment this, and let me just grab the same thing, paste it over here and comment it, and pop item can't take any arguments. Yeah, it can't take arguments, but it will return a key value pair in return. Okay, now when I run that, obviously the latest added thing to the dictionary is ismail, right? This is the latest entry to the thing. Okay, if at all there wasn't this ismail thing, the latestly added thing will be the favorite food, which will be the favorite food item, because in an order this is the last added entry into the dictionary. So now, as of now, ismail true is the property key value pair that is being added lately. So that the pop item will return, delete it and return it to. So if you want to see that returned thing over there, I can take it as returned tuple. Why am I naming it a tuple? You'll get to know. Because it will return a tuple. I have named it that way, guys. You should have understood that. See, it's a tuple. Ismail, comma true. That is the key value pair. It will be returned as a tuple. Okay, pretty cool. We can do that using pop item method. And we also have, similar to all other data structures, we have the very boring clear thing. You can be like my dict clear and print my dict. When I run this, I get an empty dictionary. See, this is why we didn't get the same thing in sets. We get the set constructor because we use the same curly braces in both of them. Okay, and again, the fourth reason being the dictionary itself can be used in a new dictionary, right? Reassigning is possible. Let me comment this. Let me comment that. Okay, now this is the dictionary initially, and reassigning is also again possible. And now when I print the new my dict, when I run that, I get name Rahul SriRam, gender male, hobbies to the hobbies array that we have created initially over here, which we didn't use until now. Okay, cool. So that is why it is mutable. Okay, justified. And I think that's pretty much it, guys. Yeah, the del keyword as usual. We can remove a pair with a specific key using the del keyword. We can be like del of my key, and what are the things? Gender, for example. I want to delete the gender, and whenever I print my dict now, I won't be able to see that. Okay, name Rahul SriRam, and hobbies, directly hobbies came in. There is no gender because similar to lists and sets, we can delete it based on indices. No, in sets I think we can't do that. In lists we can do that. Okay, based on indices. But here in place of indices we get the keys. Okay, and obviously to erase the memory itself from the dictionary itself from the memory, we can use this without using the squiggles and all. Now when I try to print it to the console, that isn't possible because that is taken out from the memory. Name error, my dict is not defined. Okay, cool. Now there are some important methods when it comes to dictionaries. Okay, so where do we use them precisely? I'll comment this too. Okay, now this is a dictionary. Accessing keys, values, pairs of a dictionary. Okay, how do we access the keys and values and the items as tuples? So if you want to access the keys, it can just be like print my dict dot keys. Keys is a method. It will return a list of keys. Okay, if you want to see that, when you run that, you see you get dict keys, which will be a list of keys. Okay, and I can also use the values method. What does this values method do? It will return the list of values that are being in the my dict. So my dict dot values, print it, and let me comment this to there. And when I run this, I get dict values, and I get all the values in there. Rahul is a value, SriRam is a value, 20 is a value, not 19, and favorite food, the list of favorite food is a value. Okay, that's great. Now, yes, so, and items. As we have known in the pop item thing, while we did that, it returned a tuple, right? While we did the pop item, it returned a tuple. Okay, it will return a return tuple of key value. It will be a 2-value tuple. Similarly, for pace, we can use the items method. It can be like print mydict dot items. And what does this items do? It will return a list of tuples of pairs, and each tuple will be having two things only, the key and the value. So it will be pairs. And now, let me comment this. And when I run that, see, dict items, it will be a list of tuples, and each tuple will be having a key and a value, a key and a value. Again, the list is being closed here. Okay, so that's pretty much it, guys. Now, copying dictionaries, deep versus shallow copying, it's the same old story that we have been discussing till now. This will be discussed in the later videos. And there are some other methods apart from items, keys, values, and clear and all. There are other methods too, like update, set, default, and from keys. Okay, we can use these for solving some complex stuff. Similar to list, set, and tuple comprehensions, we are having dictionary comprehensions too. And the very, very, very interesting topic, in the most, how whatever you name it, every emotion comes under the topic. Zipping, unzipping, packing, unpacking, the splat operator, and using the enumerate functions and enums data structure. All these we'll be discussing in very great detail with dictionaries and also with functions. Okay, we'll be using packing and unpacking in functions too. We'll be passing dictionaries as parameters, and there's a hell lot of stuff to deal with. What is packing and how can we use that? It deals a lot while coming into name parameters in functions, and multiple parameters and default parameters. There are many other things, optional parameters. There are many types of them, and we will be discussing all of them using here, and the splat operator too, which will be similar to the exponentiation operator, like this. But where can we use it and all? Okay, enums and enumerate too, we'll be discussing in great detail. So these are the 4 data structures, guys. Python data structures 7th module, but other iterable too. This is another iterable. People don't generally include this with all these, but I think it's quite similar to them. So it is a special data structure to create a range of numbers with a given step. So what is a step? I'll get into that. But mostly, to be very precise, these are used to create arithmetic progressions, and these are mostly used in for loops. Okay, parameters, the start, the end, and then comes the step. Okay, the start is inclusive, right? Like based from 1 onwards, the arithmetic progression starts, and until 11, but not 11 included. So end is exclusive. So 1 to 10 only this range will be operating, and 11 won't be included. And the step defaults to 1. Okay, by default, if you don't mention any step over here, okay, if you don't mention a step over here, or and if I try to print range, and we can access the range, the values of that range using the squiggles and array based list based indexing sort of. So when I do that, the first element in that range will be 1, obviously, because it is starting with 1. The second thing will be 2, because between 1 and 2, with a step of 1, the next element will be 2. Okay, and then comes 3, 4, and 5. So now when I print this, we get 1, 2, 3, 4, 5. But if at all I increase the step, okay, I give it a 2, then the first thing will be the first element A. If I am talking in the terms of arithmetic progressions, the first term will be A. The difference between the terms will be D, and the last term will be L. So this is L plus 1 to be precise, and this is A, and this is D. Now what happens? The first thing will be 1, and the second thing won't be 2. It will be skipped because we are skipping by 2 and not by 1. So it will be 3, and then comes 5, and then comes 7, and then comes 9. Okay. Now when I do that, I get 1, 3, 5, 7, 9. So it is quite useful while we are using for loops and all. We'll get into loops after completing data structures, and ranges. We'll understand more of ranges while we discuss the concepts of yield and iterators, generators, iterables, itertools, and all. So there we'll be getting into dunder methods, and there is quite a much to deal with. Excited to teach all that stuff. So yeah. So, and what happens if I try to access something which is not in that range? Obviously it will raise an index error because that index is not present in the range object. Okay, so yeah, that's pretty much it to discuss about ranges, guys. And you can't just print range like that, like I can't be like my range, and you don't expect it to be like a list where you pass in a list over here and you print all the list to the console. No, that isn't possible. When you try to do that, you get a range 1,11,2, the same thing that we're doing over here. Okay, it's pretty annoying, I know. So that is why we don't use this in so much in day-to-day normal data structures related stuff and to store data and all. It's used mostly for loops and creating arithmetic progressions and all. So that is another data structure that I wanted to make sure you people understand, because that forms the basis of generators and the yield concept and next method and the iter method and iterators and all. So we got into operators. I told I'll be discussing we have done with input, output, variable, data types, typecasting, operators, membership functions will be discussed in data structures. Okay, conditionals we are done, and scope also I did, and I did all these 5, and now we're at constructor functions. It's great. When I get into membership operators, what are these? There are only 2 membership operators, in and not in. Okay, for example, we have a string called seashells. Oops, shit. She sells seashells in the seashore. Why did I even write this? Okay. Yeah, so I think this is a tongue twister. We are having a string over here, and we want to check if the substring C is present in this main string. So we can also use some string methods like string dot sub and str and all that. We can do that, but we can do that in using the simple membership operator. Like, is C a member of this my string? Okay, that is what is being checked over here. Okay. Membership operators not only operates on the data structures that I've discussed here, but also on strings. Okay. Yeah. Let me comment this and comment this. I'll use the membership operators on each and every data structure so that you get a clear picture of what is happening and all, how we can use the data structures and everything. Yes. Cool. Now when I try to run this, I get present because C is a part. Actually 2 times it is being appearing in the complete my string, so it is present. If C in my string, that is if C is a member of my string, it is present in my string, then we will get a present and not. Okay, and not in is just the opposite of it. Okay, whenever I use the not in and I try to print it, this condition fails, right? Not in returns a boolean of false. It decomposes into a false. It reduces into a false because it is present, and we are asking if it is not present, and it will return a false, and else the condition will go to else, and this will be printed. Okay, cool. Now, how can we use these membership operators in lists? We have done with strings. Now we are going to list. I'm having a list, my list, a complex number, float, and this. If I'm checking if 1 is present in my list, and it will print a present, obviously, because 1 is being present in that. Similarly, in tuples 2, I'm having a tuple, the same tuple actually, I think. Instead of Rahul, I changed hero. I don't know why. God, my naming. Okay, so is hero, if hero not in my tuple, then we print not present, and it is present. Why? Because we are printing not present if hero is not present, but hero is present, and that is why it will print a present. Like, I've changed these to 2 while doing the not in here. Okay, don't get confused. And then comes sets. Okay, in sets 2, membership operators can be pretty much used. It's quite the same in every data structure. Okay, I'm just doing it because you understand it. 43 I'm having 2 times. When I run that, obviously I get a present there, though it's only a single time will be present, and obviously a 2.2 will do 2. When I do that, it will be present. Okay. Now, how is it in dictionaries? We have this dictionary. And first running is C++, second is Python, and 3 is Java. By default, the keys are used to check, but we can use the keys method to check that too. What I meant here is, dictionaries are like having tuples of items, right? A tuple of 1, C++, tuple of 2, Python and all. It will be storing data in that form, in the key value pairs. It is not like a single entity will be present as completely different unique identity in each of the data structure. Here it will be having pairs in quantities. So how do I check the Java? How do I check Java in keys, or if I want to check Java in the values. So that depends. So we can use the methods that we have discussed in dictionaries, mydic.keys or mydic.items or mydic.values. We have discussed 3 methods for accessing keys, values, and tuples of pairs. By default, if you don't use any methods, it is the same as using the keys method. Okay. Now, if I run this, I get not present because Java is not present in keys, but it is present in values. Okay. And it is the same as doing this. Oops. Keys. Okay. Now when I run that, it's not present. Okay. By default, keys are used to check, and we can use the keys method to do that too. Okay. But if I want to use values, okay, and now when I do that, again not present. Why? Because I'm using a not in operator here. I'm asking if Java is not present in the values list of my dictionary, but in the values list of my dict, I'm having the pipe Java, so it won't be true, and it will go to else, and not present will be printed. Pretty cool. Now in membership operators or in conditionals, I can use a tuple over here too. Like we've been using a single thing over here, right, to check if this is present or not present in this. But we can use a tuple of items when we are doing with items, because items is tuple like data structure. So now when I run this, I get present because 3, Java is present. 3 and Java is present in the item tuple because it will return a list of tuples, which of pairs. Okay, that's great. So these are membership operators, guys. There are other data structures like context managers and enums too. Not only lists, tuples, sets, and dictionaries and ranges. We'll be discussing them in great detail. So similar to the int function which we use for type conversions, and the str function and the bool function, there are the list, tuple, set, dict, and range can be also used for type conversions, because the data type, as we have seen, is given as class list. So list is a class, tuple is a class, range is a class. So these classes will have constructor functions by the same name, and those can be used to convert and change the types of list to sets and sets to tuples and whatever. We can do anything with those. Now, so here comes the concepts of iterable-constructors. So these are iterables, and the constructors of these are known as iterable-constructors. So the thing is, we are given a task to create a list from other iterables. Here is a tuple, here is a set, and here is a dictionary. And I wanted to create a list out of my tuple. So what I do, I print my list 1. And when I run this, I get a list of 1, 5.5, complex, boolean, string, and 1 again. Okay, see that? I have typecasted this into a list, and now it is a list. Okay, I'm storing it in my list. Similarly, I can do my set too. Okay, now when I use my set, obviously the duplicates which are 1 and 1 won't be considered, and in sets, as I told you, the booleans will be considered, so it is gone. That's it, guys. So I get 1, Johnny, 3, the complex, and the float. Okay, all of them are here. Now, so set and tuples can be converted to lists this way, but the most important thing is we shouldn't confuse using the squiggle operators. For example, I can't be like my list 1 equals to, because I've seen many people doing this. It's a very big error. When I go to my tuple, and here also let me change it to my tuple, print my list 1. Great. See, here I'm using a list constructor to convert this tuple, and here I'm just wrapping it in squiggles and passing it here. And now when I run this, the first thing will be a list itself, but the second thing, what it will do is the whole tuple as one item, and it will be the only item in our list. Okay, we are initializing my list with a list with the only item as this thing, so that you see that it's a list only, but it will be having a single item of a tuple. But all the tuple items won't be considered as unique items and won't be spread on the list. Okay, so do not confuse. While you're typecasting, don't use this, only use that constructors thing. Okay, now that's great. By default, dictionaries, keys and values are already returning lists. As I told you, dict.keys and dict.values, they return lists only by default. So I don't need to typecast them back into lists and all. by default they'll be getting into list. But if at all you want to do so, we can do it. And this task is completed. We have created list from other iterables. Now we're going to create a set from other iterables. Okay. For example, I'm having my set 1 equals to set of my tuple. Okay. And what I'll do, I'll maintain my list same as values, but different in the type of the data structure. And I'll copy and print that my list, my set 2, and this is list 1. And now when I print set 2, that's great, guys. Now we are having a list here. I think I can name this my list here too. Okay, yeah, we are having a list and we are having a tuple, and we are creating new two sets. Set 1 equals to the tuple thing, and set 2 is this thing over here. What are we doing? When I print those, I get the same things, because the tuple will be converted and the list will be converted. These both are the same things. There is no much difference between the tuple and the list except for the data types, and this will be the same. But if you observe, duplicates are being deleted. While we go to list or the tuple, we are having 1 twice. Okay, and in the list 2 we'll be having 1 twice and all. Okay, but here only once it is being recorded, because while converting it to a set, we're typecasting it, the duplicates will automatically be taken out because it should be converted to a set. Okay, so if at all you're having any competitive programming problem where you want to delete the duplicates of some data structure or a set of elements given to you, you can just typecast. You can take an entry as a list, because list will take duplicates in, and if you want to take out all the duplicates out of it, we'll convert it into a set, and again you can convert it into a list back, and then boom, all the duplicates are gone. Okay, that's great. So that is how we completed this task. We have used these other data structures to do that. Of course, if I want to be like, my set 3 and equals to set of, I'm having my dict of keys method. Wait, what is keys? Yeah, okay, the keys method. And when I do that, and when I print that to the console, I get first name, age, and last name, which are the keys of first name, age, and last name. Okay, this is overridden, by the way. I've already told that. Okay, and I've converted them into set. By default, we return a list, as you know, but we are converting them into sets. I can also do the same for values. I can't do the same for items, because items will return list of tuples, and converting them into sets, we can do that actually. Can we do it? Yeah, it will be a set of tuples instead of a list of tuples. It will be a set of tuples now. That's quite common. Okay, so that is it with this module, guys. Next we'll be moving into loops. Okay, so now that we are done with data structures, let's get into loops. That is the 8th module. Okay, so loops are like we are having some data structures, right? So we can also write a collection of elements, and over them we'll be able to iterate through them, so that we can access each and every element in that collection or in a given range, or until a condition is satisfied, we can do anything. So there are 3 main uses of loops. This is used for the repetitive execution of a single statement with another parameter, or on each element of a collection, or until a condition is satisfied, and for there is some repetition involved, so it is known as iteration or looping. So because a loop, how a loop looks. So alternatives of loops and iterations is recursion, which I won't be discussing in this video, but I'll be introducing you to functions and some recursive functions too. Okay, so loops are used to iterate through a collection, and while iterating through a collection, we'll be using a for loop, and we can also iterate until a condition is satisfied. And for such kind of loops, we use a while loop. For such in such scenarios, we'll use while loops. We can also use a for, but while is preferred. And on iterables, like until we have discussed 5 iterables, lists, sets, tuples, data, dictionaries, and ranges. So over them we can iterate we'll be able to iterate using loops. Here there is nothing specific like we'll have to use only for loop or only while loop and anything of that sort. You can use both for and while loops. So yeah, so let's get into collection of elements. So generally we'll be using a for loop, as I've already mentioned. For example, this is a collection of elements. See that 1, 2, 3 and 4. If you observe, that is a collection of elements. There are no square braces and flower braces around it. So it is not an iterable, but it's just a collection of elements. So while iterating through them, I can take in using the for in loop, where in is like the membership operator for every x in this collection. Okay, this is how we read it. For every x in this collection, where x will be, and the first time it will be 1, then goes to 2, then 3 and then 4. Okay, so now when I run this, okay, wait, I think I'll have to comment. Yep, I should. Yep, cool. Now when I run this, I should get 1, 2, 3 and 4. Okay, by default the end parameter of the print function, you see I've not discussed. There is other parameter too, like separator. See that? Okay, we use that while we are going through iterables and all, but don't worry about these both right now. By default the value of and is /n, which is a new line. Okay, but I am overriding it to this thing and equals to space, because if I run it this way, I'll get 1, 2, 3 and 4 in different lines. Okay, but I didn't want that to happen, so I was just adding this space, so that we'll get space separated integers throughout that collection. So this is known as a collection, and while iterating through collections, it is preferred to use for loops. Okay, so this is the syntax. We write the for, and we'll take name each parameter in this with some name, variable name, and we'll use the membership operator n, so that x in this collection will be applied to the for loop, and it will repeat until this collection is completed, until each of the elements of the collection are iterated through. And then under the scope of this, like in this 4 tab spaces, I can write as many statements as I want. Okay, cool. Now yeah, that is for loop, and that is how we iterate through a collection of elements. And the second is we can iterate until a condition is satisfied, and in this case, like in this scenario, we'll be mostly using while loops. Okay, so for while loops, the pretty simple way of doing it is, first we'll initialize our variable, which is also known as the iterator, but not specifically iterator, but at times it is known as the iterator, the initialization of that variable. And after the while, I'll write a condition until when the loop should continue and iterate through. Okay, so this is the condition, and to increment and all, I write the increment statement over here. Okay, so I equals to this, I less than this, and I plus equals to the step. You can take 1 or 2 and whatever, it doesn't matter. I'm just incrementing it with a 1, and I'll check only the first 5 numbers, so until less than 6, or also I can write less than equals to 5, anything, it doesn't matter. So until this condition is met, until this condition is true, this loop will be running. So it's preferred if you're having a condition and only this number of times this will be running. If you know anything of that sort, it's better to choose while loops. Okay, now when I run this, I get 1, 2, 3 and 4 and 5, because 1 is the initial statement, 1 is less than 6. It gets into the loop because this condition is satisfied. It will print, and I is incremented, and again it will come to the statement over here. Okay, so this is why we call it as a loop. The statement over here completes, it increments, and again the condition is checked until the condition is starts getting not satisfied, and it fails. Until then it will be in the loop and it will be running in a circle. Okay, that is why it is known as a loop. Cool. So yeah, so for the second kind of scenarios, we'll be using while loops mostly for until a condition is satisfied and all. Now we are having our iterables, which first I'm considering a string. So in strings, since we have index-based access, we can access, like, for example, the variable my string, and the first character is b. I can access like my string of squiggles 0, the square braces 0. So b will be my string of square braces 0. Since there is index-based accessing, we can use while loop, and obviously since it's an iterable, we can use a for loop. Okay, so yeah, let's iterate through any string using the for loop. I'll take for each character in the string the skinny coder, Okay, let me print that character. By the way, you see that char is not syntax highlighted because there is no data type called char in Python. Now when I run that, oops, what's wrong? Now when I run that, I get the skinny coda. Okay, if you think that's quite confusing, I can just change the default to nothing so that it will print as like this. Okay, so it is iterating through each and every character, and that character is being printed, and this keeps on running in a circle. Like character is T, it prints, again it comes here, it goes to H, it comes here, it goes to E, and it keeps on repeating until and unless the string is completed, until the R is encountered. After R, this loop breaks. Okay, so yeah, so this is how we iterate through a string using a for loop. It's not only right, we'll have to use a literal over here. I can just take that into any variable like my string, and I can put in there, and here I can use my string. Okay, anything is the same, it doesn't really matter what we are using it. Okay, we get the same output. Cool. Now, okay, these are also known as advanced for loops, or range based for loops in other languages, but in Python this is how we do it. And now we have the string Batman. Okay, and I want to use a while loop to go through that. So string based in Python, array indexing and string indexing all starts from 0. So I'll initialize my counter variable to 0. Well, I can take that as count2 if you want, or counter, like to be more precise. So now I'll write while counter is less than length of Batman, right? Oh, so not length of Batman, it's my string. So it will be less than the length of Batman only when it is at the last character, right? I'll get to that point again because there is something confusing. I see many people getting confused over there. So let's see if we will get a mistake, or if we are getting a mistake, why we are getting a mistake. Let's go through that detail. Now I'll be printing each character because the count is a variable now. I can be like my string of counter. Okay, that's cool. Now I'll have to increment the counter. While writing while loops, you'll have to increment the counter like any counter variable. If you're taking it inside the loop only, else it won't be possible. It'll get into an infinite loop. Okay, now I think I'll just comment that out and let's run this. Okay, forgot to do that. Okay, what's wrong with? Okay, cool. Now when I run this, I get Batman. Okay, so yeah, since it's array zero based indexing, and the length variable does not count from 0, but if there is one character, it will count it as 1. So the length of this will be 6. Okay, so this counter less than length of my string will be satisfied until and only counter variable is at 5. Okay, when it comes to 6, this loop breaks, and that is what we want, because there is no my string of 6 available here. The last character is my string of 5. Okay, so don't get confused. I've seen people writing this way, though they are using length over here. If at all you're doing it this way, then you'll have to add a -1 over here. Okay, else you can just use a less than and remove that -1 over there. Okay, cool. So this is how we iterate through strings using while loop. We have seen how to do it in the for loop too. Now we have lists and tuples. Both have, similar to strings, index based access. So obviously we can use both while loops and for loops in the same way we did over here. So what I'll do is I'll just copy this thing, because that is what I'm going to use here. And let me first uncomment it, and I'll take a list here. A very simple list, 1, 2, 3 and 4. Okay, and I'll call each thing as element. Cool. Now when I run this, I get 1, 2, 3 and 4. Okay, I can just put a space in there, and I can again run. I get 1, 2, 3 and 4 with spaces in between. Okay, cool. So that is how it will be like in this list which we are giving it here. See, this is not 1, 2, 3 and 4 as we have done in collections. Okay, this is a collection of elements. That is also possible, but this is mostly used while we are having this list stored in a variable. Okay, for example, my list equals to I'm having this Okay, so now when I store it in there, I can just use the variable name over here so that it'll iterate through it. Okay, cool. Now, yeah, this is how we use the for in loop on list too, because the element will be, at the first time it will be 1, it will print it, again it will get back to the statement, it will this time be 2, and it will keep on iterating until all the elements are completed. Okay, this is how we use for loop. Now, for example, I'm having a counter equals to 0, again it will have to be 0 because even list based and tuple based indices will be 0 based. Let us take this as a tuple actually, because we have already done with lists and I think it's pretty much the same. Now use while counter is less than equals to, this time let us do this way. Okay, my list minus 1. Okay, so here started the scope, and the whole of this is the condition. We don't need to put those parentheses or braces over here, it doesn't really matter. Okay, this will be turned into a boolean using the precedence rules and all. Okay, so now while counter is less than equals to length of my list, I think I should name it my tuple. See, I'm being very precise because I'll be pushing this into my GitHub repo and you people will have access to this code I'm doing. So you shouldn't get confused if I name this my tuple, my list, and I'm writing a tuple over here. Beginners will get really confused about that. So be like print, not my list, my tuple, and the counter variable in there. Okay, so I'll also give that end parameter and I'll change it from default to a space. Okay, and the most important thing, we should update our counter variable, else that won't work. Okay, so I think I'll just comment this because we're getting confused. Cool. Yeah, 1, 2, and 3, 4. Okay, now we are iterating through a tuple. Okay, we are using that less than equals to len minus 1. Cool. So this is how we do it in lists and tuples, because even they are having index based accessing. So even while loops are useful. But when we come to a data structure like sets, okay, we can use only for loops because index based accessing is not possible, right? We know we can't use indices over here, so it can't be like because every time we use a for loop, while loop, you see that I'll be like the data structure name and I'll use the squiggles over here, okay, to access each and every variable. But that is not possible in sets, so only for loops are the only way to iterate through sets is by using for loops. And the most important thing is in sets, as I already have been mentioning from I've started sets, they'll be very random and unordered, so we don't know in which order this will be printing. Okay, now when I run this, you see I get x and then 1 and 3 plus 4j will be pushed to the last and 4.3 comes in. Okay, so if at all I take that duplicate, you see even the duplicate is not being iterated through, only once it is being iterated. Now I get that 4.3 in the first thing, x goes to the middle, and it's very pretty random. Okay, we don't know, but each and every item, unique item in the set will be iterated through and it will be printed to the console. Okay, so we can use only for loops, we can't use a counter variable, and we can't access the element at that position using the counter variable because that is not possible in index based accessing is not possible in sets. Okay, so yeah, we're done with sets too. Now ranges, as I've already mentioned in ranges over here, these are special data structures and these are excessively used in for loops. Okay, these are used to create arithmetic progressions. Okay, like what we are doing with while loops, every time we are incrementing it with only 1, right? I can also do it with 2. Okay, now this is what acts as a step function in our ranges. Okay, the step parameter that we are giving over here, the third parameter. If at all I'm putting as 1, I don't need to do that because by default it will be 1. Only 2 parameters can be passed. So that is an optional parameter. Functions can take optional parameters. We will discuss that later in this series. Now yeah, so ranges, these are used in for loops, and we are given a task to repeat the while loop tasks with for loops using ranges. Okay, like what are all the while loop tasks that we did till now? Let us check it out right from starting. For this is a while. Okay, what am I doing? I equals to 0 until I is less than 6. I am printing it, right? I can do this using for loop too by using ranges. Okay, so let me use ranges now. The first thing is for x in range less than 6, right? So we know that the start variable is inclusive, so we'll take 1, and the end variable is exclusive, so I can't put a 5 here because until 1, 2, 3 and 4 will be taken and 5 will be excluded. I want 5 to be included, so I'll be using 6 over here. Okay, and the step is 1. I can use pretty much anything, but since 1 is the default, I don't need to mention that. Okay, now I'll be like print x. Okay, and I want n to be separated thing. And now when I run that, I get 1, 2, 3 and 4 and 5. Okay, the same thing that we did here, the same thing, the while loop thing we did over here, I'm doing with using for loop using ranges. Okay, now let us go through strings too. I think for using strings like accessing through strings and all, it's tough to do that, obviously, but like there is no point in using strings and all. Okay, for example, we are having a string. I'm having a my string. Let me uncomment that. Where is it? Not only on strings, and on any iterable, while you're dealing with other iterables, there is no point in using ranges in there, because you can directly iterate through them using the for loop. And why do you again want to write range through and access through the element and all? So when I get here, I think I'll just uncomment this. Okay, my string equals to the skinny code, so that I can use that over here. Now what I'll do is I'll comment out these both lines. And over here for character position, or why not put it as index? Okay, index in range of the string or any iterable ranges starts from 0 based indexing, and until the length of my string, we can just take that. Okay. And since it's exclusive, I don't need to write a -1 over there, because anyway, length until len is satisfied, it won't go through. And I'll use the default step over there. Now I'll use the print statement and be like my string of index, since index based accessing is possible, and equals to nothing, because I want it to print without spaces in between, and it's pretty much possible, right? But if at all you're using a for loop, why do you want to complicate it using ranges and again using the index based accessing and all? It's pretty tough to do. Instead of doing that, I can just iterate through the string using this syntax for n loop, okay, using the in operator. So if at all you're using ranges, that should be only when it should be like an alternative to the condition is satisfied kind of loops, where you can use only while loops. Okay, so ranges are used as an alternative to this section 8b over here. Okay, so yeah, we won't be doing this much. You don't see people doing it that often. This is like foolish. Okay, so yeah, we're given another task: print the first 10 odd numbers. It's pretty much simple. See, the first odd numbers, like between every odd number, 2 numbers difference is there. So the first thing will be 1, obviously, that's the first odd number. And since he asked first 10 odd numbers, since the step will be 2, I think the range should be till 21 and not 20, because 20 will be excluded. It doesn't matter, because the first 10 odd numbers will go through only till 19, 20 or 21, it doesn't really matter. But because it's a double, I just took 10 to 21 over here. And the step is 2, obviously. I can use a for loop too, and I can be like I plus equals to 2 in the iteration, but we can use range based loops for simpler syntax and less number of lines of code. And I'm printing it with spaces in between. So now when I run this, I get 1 to 19. These are the first 5 and these are the next 5. Okay, cool. So this is how we print the first 10 odd numbers. Now, there are 2 special statements when we are discussing about loops, and those are the break and the continue statements. Okay, so to get the same output over here, now I'll use a while loop. Okay, like you see, this is what goes in programming. We can use any kind of loop we want. You can use any structure, or there are many alternatives to solve a single problem. We can do how we want to, but it completely depends on us and the space complexity or the amount of code you're writing for it, or how much time you're spending on it. Is it an efficient algorithm or not? It completely depends on that, and there is no restriction. You can use whatever loop or whatever structure you want to use. Okay, so I'll first take I equals to 0, or no, I equals to 1, because the first odd number is 1, and while I is less than 20, okay, I'll be like print I. okay, and equals to this space. And now I can be like I plus equals to 2, update the counter with a step of 2. So now next time I will be 3 and not 2, okay, since I'm incrementing it twice. Now this is pretty much possible, but so that I can demonstrate the continuous statement, what I'll do is I'll use an if statement over here. So before printing this, I'll check if I is an even number or an odd number. So how do we check that? I percentage 2 equals to 0. Obviously, because it is an even number, we want to continue. The continue statement comes in here, where we can just, if at all we are having I as an even number, then this print statement won't be executed. From here, it will go to the next iteration. Okay, like the updation will happen and it will go there. And before doing that, I'll have to update it, obviously, because I'll have to print it over there. And again, it always that if statement won't be executed. So again, I'll have to use that plus equals to 1 over here too, because if it is not if it is an odd number, it will print and again it will again come to the loop with the same number, and we don't want that to happen. We want to iterate it. Okay, so that is why I'm using increment operator twice, once for even numbers and once for odd numbers. Now when I run this, I get 1 to 19, but if at all it is an even number, we are stopping the execution of the loop over here and we are going to the next iteration. Okay, that is what is happening. But there is another statement too, like until and unless a condition is satisfied. For example, if you are having anything of that sort. For example, I'm having or a while loop at least. Let's take a while. While x is less than 10. Okay. Initially, I'll be taking x is less than 10. I'll just put that over here and comment all this. Maybe I'll have to take that too. Great. Okay, so I'm having I less than 10, but we'll check a condition that let us break the loop if it is at 5. Okay, like there is no point in doing all this, I know, but like if you know that we are going to break the loop at 5, why not take it in the condition itself, like while I less than 6 or less than equals to 5. But just to demonstrate the continue and the break statements, there are some very beneficial use cases of them too, but I think I didn't want to confuse you with complex programs and all. I just wanted to show you the real usage of them. Okay, so I equals to 5 will be breaking the whole complete loop. And what's the difference between break statement and the continue statement is, in the continue statement, it will again come back to the loop, but anything after the continue statement won't be executed. But in the break statement, what's wrong? Expected to be okay. Yeah, I'll have to check if I equals to this. Okay, yeah, I'll be breaking it. Else, I'll just print I, and I'll give the end parameter to space. Okay, cool. Now again, don't forget to increment it because we are using the while loop. Now when I run that, only till 4 it is being run. Okay, and when it is 5, we are just breaking it, we are not printing it. And after this, it can see if at all you think I plus equals to 1 here too, like we did there, because you may be thinking that since you're stopping the loop over there. No, it doesn't matter. Even if I am incrementing it to after checking it, even if I am incrementing it to 6 and I'm breaking the loop, after coming here, it will come into the loop and it will be like, okay, 6 is not equals to 5, so I think I'll have to go here. No, that doesn't happen, because the break statement itself occurs and the whole complete loop will be stopped over there. There is nothing like it will again go to the loop and the bottom statements won't be executed. That is the difference between the continue statement and the break statement. Okay, so after the break statement, the loop whole out of it will be coming out like this, and all the other program under the while loop or any loop that you are using will be continued in the execution. Okay, so that is how we use break statement too. We can also use an else clause in loops for example, until the for condition is satisfied, we'll be printing something, and else if at all that condition is not satisfied, we can print something. Okay, there is something of that sort too. We can use else clauses on loops, but I won't be discussing that in this video because there is something else I'll have to discuss about loops and ranges and generators and iterables. There I'll be discussing this. Okay, so that is it with loops, guys. Okay then folks, so now that we are done with loops, let's get into the ninth module, which is functions. Okay, so I won't be discussing pretty complex topics about functions. This module will be very short. I'll just write all the 4 types of functions that are possible in any programming language. So that is it. So yeah, this is how we define a function. Okay, def keyword will be used, and after that we can write a function, and we'll be having braces over there, and if at all we are having any parameters, we can pass the parameters over here. Okay, then the parameters should be variables. We can't just pass literals or constants over there. Okay, we can do that in some other form, but like you see, if at all I'm not writing any statement over here, I get an error, right? Obviously we'll get an error. Function definition empty or something of that sort. Okay, obviously see that that's the red color. We are getting an error over there, because I just didn't want to write any statement under the function definition. So there is a special statement in Python called pass. Okay, when I write the pass statement, it will be like there is something in here, but as of now I won't be writing it. Just declare and leave it. Okay, so that later on, after completing the remaining code, I can again come there and we can complete it. And until then, it won't disturb us, and that red lines and all, it won't look ugly, and it won't be showing the error over here and all. Okay, so we can use the pass statement for that. Pass is also possible in conditionals. Like if at all I'm having an if over here, for example, I can select pass. Okay, and I can just comment out this both. That is possible. Okay, now this until we can just go to over here and we can come to pass again. So that I can remove this pass statement and write what the logic I thought of writing, but I took a time to write that. Okay, so pass statement can be used in conditionals. So since we can use them in conditionals, even in loops we can use them. So while we are handling with loops, after the condition under the loop, I can write be like pass like this. Okay. Yeah, awesome. That's because I'm having a space over here and all. Yeah, I can use pass over here. Okay, that is also possible. Now, let's get into functions. For function definitions and for class declarations and all, I can just leave them like this with the function, because I can come back later and I can fill that up. Okay, now we use the def keyword to define a function in Python, be it a method inside a class or a normal function and a global scoped function. Everything we use the def keyword only. And we write the function name, and we use the braces over here to pass in any parameters if we are having, and we'll use the colon, and after that colon we'll have a scope created for us, and only in that scope we'll have to write all the function definition. We can also call the same function over here with other parameters, so that we can use recursion and all those topics. But recursion is not something related to Python, right? It's a programming concept. So since it's a Python crash course, I won't be going into details of all that, because that's a global topic, not a language specific one. Now, okay, so the task is to write a function taking no parameters and without a return statement. Cool. It won't take any parameters, so the parameters braces will be empty over here, and there is no return statement. Functions can return some statements so that we can assign those functions with some parameters or without some parameters to other variables outside the function scope, so that we can use those variables in other print statements or whatever way. So I'll be demonstrating what is the return statement in the next section. So here we are having a print statement. Okay, that is the most we can do without a return, because yeah. So you see that print. Let us print the hello world. This is known as a function definition. And now when I run this, nothing is going to happen, because we've just declared and left it. Okay, we have defined the function, what it should do, and what all should be happening if at all the function is called, but we are not actually calling the function. And to call the function, we just use the function name like that. Okay, now if at all it is having any parameters, we can pass the parameters, and if it is not having parameters, we won't be passing it. And if it is not returning anything, I can just call it like a statement over here. If it is returning anything, there are 2 ways to handle the returns of a function. I'll be discussing them. So here now I am calling the function line by line execution piece, like the interpreter comes to the line comments, these both will be executed left around, they won't be executed, and then it comes here, it will see that a func1 is being created, and it will store the definition of it in memory, and when you see the function call over here, it will go back to the definition, and that statement will be executed, and again it will be coming back here. Okay, so it is a block of code, a reusable code, so you can use it everywhere you want. Anyway, I can call it multiple times before and after some statements too. Okay, So now when I run this, I get a hello world, okay, because as I already mentioned, let me repeat myself, I'll get into the func1 thing, and there is no statement after this, okay, everything is comments and doc strings. But since this function is called, it will come to the definition, all the statements under this scope will be executed, and it will come back here, and after this again the program executes, and since there is nothing, the program kills, okay, so we get hello world. Now this is a type of function which doesn't take any parameters, and it won't return anything, but will just do something except for returning, okay. It can also increment a variable, and it can do anything, not only print statements, it can do anything, but it won't return anything, like there is no return keyword used over here. Now let us write a function which takes in a parameter but without a return statement. For example, now let us write a func2, and it will take a parameter called number, okay, and under the scope I'll be printing it number, okay, or I can also use the parameter is str. Remember that typecasting dealt with while using arithmetic operators and strings. If at all this is a number, if at all this is a data type of a number, there should be a string over here, okay, and it doesn't matter if you are already passing a string. See, for example, I'm having func2, and it is taking a parameter, okay, it is taking in a parameter, we don't know which function it is, like any parameter, or we are not, since this is not a typed language or a type specific language, we can pass in any parameter and it will be acceptable. Now if I am passing 5 over here, now this number will be taking an integer and it will print that integer, okay. Now when I run that, I get the passed parameter is 5, but here 5 is taken as a string, okay. If at all I remove that string, when I run that, I get type error, because while concatenating with print other things, I can the data type int can't be typecasted into it. But if I pass a parameter like this 5 or 55 or as a string 56 and all, this is pretty much possible because we are passing a number but in the form of a string, so concatenation is pretty much possible. That's it. So it's taking a parameter, and that parameter will be used over here, and it's like we are creating a new variable with the value being passed from here. That's all. Like, how do we create a new variable? We'll take like num equals to 56, right? And this is in the global scope. Like this num over here is in the functional scope. So there is a difference between the global scope and the functional scope. Okay, the local and non-local keywords will be coming into action over here. As I've already dealt with scope in the conditional section, and I told there is a tool called LGB, and there is a lot to discuss while we get into callbacks and all. There is a lot of hell that will be happening under scope, so it will be very confusing if you don't know the LGB rule and all. Yeah, but as far as this video is concerned, we'll be creating that variable over here, and we'll be assigning a parameter from here, that value to here, and that variable is only valid until this scope is dead. Okay, after that I can't be like, since that function scope is over there, like I'm getting out of that indentation scope, and now if I try to print that num, I can't do it because there is no variable called num. You see that I get that error over here, type error or undefined variable num. It is not there. Okay, because that num variable is built scoped over there, and we can't do anything with that. Okay, so this is how we write a function which takes in parameters and without a return statement. And by the way, not only a single parameter, I can take two parameters too. Okay, I can be like num1 plus num2, and the sum is, and I can just be like num1 plus num2. Okay, now I can just put both of these under string. Okay, don't be like string of num1 plus string of num2. Okay, that will be string concatenation. That will be like if you are passing 5 and 6, it will print a 56. Obviously, like this is what is wrong with Python. Okay, see that now this will arithmetic operation happens on integers, integer variables will be added. It will be 11, and then it will be converted to a string, so that we won't get an error, type error, while using the concatenation. If at all you do that over here, that both, if we typecast and we try to add them, that is not going to work, because it will be like 56, and that is not what we want. Okay, because both of them first will be converted into strings, and between strings, if you are putting this operator, that will act as concatenation operator, but not like a arithmetic plus operator. Okay, so yeah, that is the reason behind doing that. I can be like this. Cool. So you can take multiple parameters too, and a single parameter. It doesn't really matter how many we are taking it. It completely depends on what kind of program or what kind of function we need. Okay, but the number of parameters that we are using in the definition should match over here in almost all the cases, until and unless you are using concepts like optional parameters and all. Okay, so now another task is write a function which takes in no parameters but will return a statement. Okay, now we are getting into return statements. Let me read this function 3. Okay, it doesn't take any parameters, but it will return. For example, I wanted to write a function called pi. Okay, it will always return that thing over here, and we are calculating the area of a circle and all. Okay, I will like print area is. Okay, now I can be like, the area of a circle is pi r square, right? So what can I do? For pi, I can just put on that function call over here, but I'll have to wrap it in string, obviously, because I'm trying to concatenate it. Okay, now pi r square, I'll multiply this, and for r square, let us take in a variable called r, and let it be 2. Okay, now I can be like r raised to the power 2. Okay, now if you are a bit confused, I can do that too. Now what is happening over here? I'm first calculating r square, and I'm multiplying that to the pi function, which will be returning a statement over here. So I can just put the function call here inside a compound statement of like this. First inside a string function, inside a print function, I'm using the pi function, which will just replace this function call over here with the return statement. Okay, which is 3.14, and 3.14 will be multiplied with r square, and the whole of this will be converted into string because we are trying to concatenate it. Okay, now when I run that, I get 12.56, which is 3.14 into 2 into 2. Okay, yeah, so that is how we use the return statement. Okay, so we can directly print it to the console by using, see, that is what I meant by how to handle return statements. Here we are not having a return statement, so I can directly call the function. Here I am not having a return statement, I can directly call the function. But while we are having return statements, we can handle it in two ways. One, either by printing it to the console, like this, what we are doing in here, or I can take in a variable called, name it anything, and I can just store the pi in there. Okay, now if I print that var pi, okay, and let me just comment this both and run this. Oops. And run this, I get 3.14. Okay, so the return statement comes here. 3.14 will be replaced. We'll be replacing that pi function call, and now obviously it will be assigned to that var pi variable, and we can print that to the console, or we can make updates on it, whatever. We can handle it however we want. So while we are having return statements, we can either print them to the console or assign them to other variables. Okay, that is how we use the function calls which are having return statements. Okay. Now there is a concept like multiple return statements, or see, by the way, not only this thing, I can return a string over here too. It doesn't really matter what we are returning over here, because that will be handled over here. Okay, it is not a type specific language. I don't need to mention which data type will be returned from this function and what are the kinds of parameters that we are passing in. I don't need to mention all that. It will be inferred directly while we are giving function calls. I can also return things like lists. Okay, for example, I can return things like lists and all. I can also return collections, which I've dealt here in the loops concept. Okay, these are called multiple return statements, and I'll get into multiple return statements in a later part of this series, not in this video, because that's such a beautiful concept and a very unique feature of Python. Okay, so the final task is to write a function which takes in parameters and then it returns a statement. Very simple. let us take a function called mySum. Okay. By the way, I have not named it sum because there is a library function called sum in Python, like len or type and all. So as I told you, our identifiers shouldn't have the same names as keywords. So library function names and keywords can't be used as our names to identifiers or variables and functions in classes and all. Okay, now this will take two parameters. Let us name them x and y. And what this will do is just return the sum of them. Okay. Now I can just use it in the print statement since it is having return over there, and I can be like 3,4, and this should print 7 to the console. Yes, it is printing a 7. Okay, at all your yes. No, I'll be running that again. Yeah, see that I get a 7 there. Okay, cool. Okay. Since we are having a return statement, I can use it in the print statement, or I can assign it to some statement, any variable, and I can use that variable however I want. So it is having parameters and it is returning some operation being done on those parameters. Okay. So these are the 4 types of functions we use in any type of programming language. Okay. With arguments and without arguments, with return statements and without return statements and all. But functions in Python is a really big concept, and we have some concepts like first class functions and higher order functions and lambdas. Lambdas are like the hot topic on now in Python, and we multiple arguments and varied arguments and can also be passed to Python functions, and there will be like optional parameters and default parameters. There are many concepts to be discussed. And we also have command line arguments and all. Okay, we have multiple arguments, default arguments, optional arguments, and varied arguments. Many concepts over here, and those all will be related to this packing, unpacking, and passing dictionaries and using the splat operator again. What we have discussed in the dictionaries thing in the data structures, that will be linked over here. Okay, and we can zip and unzip the parameters that we are passing in. Like this video will be a little similar to the, if at all JavaScript, the spread and rest operators that we will be using. Okay, it will be a little similar to them. Okay, so yeah, so that's it with this module, guys. So we'll be returning back with the oops module. Okay, now that we are done with functions, let's get into oops. So oops is also, like I've told with functions, it's a great concept and it is having many things to work on. But in this crash course, we'll be discussing on until inheritance and some concepts of that sort. So see, here I'm having some tasks to be completed. If you don't know what OOPS is, a programming paradigm, it is object-oriented programming, where we'll be having concepts like objects. Objects are like anything in the real world. Okay. For example, a rectangle is an object, or a human is an object, a dog is an object, a pen is an object. So anything in this world, any object in this world, like don't take that object word as in programming word, but take in like plain English. We know any object is like any entity or any body, right? So it will be having two things. It will have properties and it will have methods. By methods, I mean actions. So what do I mean by properties? Like I'm Rahul SriRam. I'll have many properties. My height is a property. Okay, so what is my height? It will be having a certain value to that. So properties will be having associated values to them. Okay. And what is my hair color? That is a string value. Okay, what is my height? That is a float value. What is my age? That is an integer value. So we can see the similarities between the day-to-day objects in how we can use them in data types and convert them into programming objects and all. Similarly, I'll have actions. I can eat. That is an action, or that is something that can do. Verbs come under actions. Okay, so these come under methods in programming. Okay, actions are methods. And properties are called attributes of a class. Okay, we'll have types of attributes too, like private and public and all. But this video is not related to object-oriented programming. And the most important thing is, even though I want to explain the OOPS concepts in Python and all, I don't think Python is the right choice to explore OOPS concepts, because it's not a Pythonic, OOPS-oriented language. It's not a completely object-oriented language. Best language and a very good language to explore the concepts of OOPS is Java or C#. So I'm also planning to do a Java OOPS crash course. Like it will be having only the OOPS concept in it and nothing else. Not the features of Java, but the features of OOPS, which I'll be dealing in Java. And even C++ is like a completely OOPS language, but not completely. It's like mostly, compared to Python, it is pretty much a better OOPS language. So, but we have, compared to other programming languages, we have classes to create objects and all. So, what are classes and what are objects? I already told you what are objects. So, when coming to classes is like a blueprint, okay? For example, you're having a civil engineer who constructs buildings, okay? So, how does he construct a building? It's not like there is a building first and he'll just create a doppelganger of that, and he'll create a copy of that and paste that building over in another area, right? He should have a plan and he should have a blueprint. So a class is like a blueprint. So we can use that blueprint to create as many objects as we want, okay? So using the class is like a definition, okay? A function definition, we declare it only one time. We write the definition of a function only once, but we can call it as many times as we want with different parameters. So similar to that, a function will not take in anything into the memory, as you know, because it's just a step of statements that will be executed, and after the scope is completed, the function will get out of its scope, and that's all. But while coming to classes and all, classes is like a blueprint. It will use, we can define the properties of our class and the methods related to that class or that object inside that class. Only definitions will be done and only declarations will be done. But we can assign values to that while we are creating objects, okay? So the process of creating objects or instances of a class, okay, we call the objects as instances too. Instances of a class is known as instantiation, okay? So in the process of instantiation or creation of objects, some programming languages use the keyword new to create objects, and heap and memory location and allocation and stack memory allocation. There are some concepts in each programming language will have each runtime, so and it varies. But in Python, there is nothing much to do with memory and memory handling because it's a pretty clever language. And in the first place, there is a variadic memory allocation, right? A string can be reassigned to an integer data type. So there itself, we know how flexible a language it is. So we don't need to worry about allocating memory and all. I can just create object to that class. So I can create as many objects as I want with different parameters, so that each object will be unique in itself. Like class is like a human, but not Rahul, okay? Human, there are many humans, okay? I am a human, or my father is a human, or my teacher is a human. Each of them will have the same properties, but each property will be different, okay? I am of the height, for example, I'm 5'9" as of now, and some other maybe of 6'2" height, but the property name is same, it is height, but the value is different. So that differs from person to person, okay? Hair color is a property that is similar to many people, or each and every human, but the value of that property differs from each person to person. Okay, so this is the basic overview of OOPS concept. So I won't be getting into details of all that. Now, what does a rectangle have? The task is to create a rectangle class and add some properties and methods. Okay, I can see I've used the pass statement to not raise an error if I'm not declaring anything in the class. Okay, it's like I can use that over there to avoid errors and all. Now, what are all the things that I can have in a class? Okay, in a rectangle, for a rectangle, the properties are length and breadth, obviously. So inside a class, I can define methods. Okay, for every class, there will be a constructor method, and we'll have to write a constructor method. There is no default constructor kind of thing in Python and all. There should be a constructor method, and as I told you, functions and methods, be it by functions I mean something written out in the global scope, and methods which are written inside the classes. Okay, so even they are declared in the same way as we declare other methods. Okay, so there is a special method for every class called init. Okay, see that it will take the parameter self by default, and oops, I don't want this already. Like I'll be using that, but not already. Okay, so yeah, we are defining a method called underscore init underscore. So these types of methods which start with underscores, double underscores, and ends with double underscores are known as magic methods or dunder methods. Okay, let me make sure you know the spelling of them. Okay, magic methods or dunder methods. I won't be discussing them over here because that is where we'll be using concepts like iterators and all, the iter dunder method and the next dunder method, and there are many other dunder methods and magic methods to be declared and used. So I think it's better to use them in the REPL, so I can show you the usage of underscores and everything in a single video. Okay, so yeah, so this is the constructor function in Python. Okay, for this rectangle, this is the constructor function. That init double underscore init double underscore is the constructor function. In other programming languages, we have the same name as the class name as the constructor function's name, but in Python we use this method. And if at all you're familiar with other languages, OOPS languages like Java and C++, there is a keyword called this, and this refers to this instant of that object. Okay, so I'll get into self, what this self thing is, and this is self keyword is just a replacement of this in other programming languages. Okay, in other programming languages we use this dot and access the attribute or variable or methods of that class. Here we use self dot. That's all. There is nothing much to do with other things or related to self and all. It's pretty much the same as this in other programming languages. So what all does it have? The init method. It'll take 2 parameters. Obviously, it'll take a length parameter, nice parented form, and a width parameter. Okay. Now I can access the length equals to length parameter, and I can write that as that, and self dot width parameter equals to width. So what is happening here? If at all you're feeling clueless, let me explain that to you. In the constructor function, like while we are instantiating it or creating an object of it, we can pass in 2 parameters, length and width. See, self is a parameter and we won't be passing it. It is like a default parameter. Just in the declaration it will be there, but while using it, while calling, we won't be using that. So we'll be using only the length and the width parameters. Now I pass in 3 and 4, for example. So these variables, the 3 and 4 containing length and width, will be assigned to that object specific property called length and that object specific property called length. Okay, or called width, and those will be assigned to them. And if at all I'm not using this self over here, the class or the object doesn't know that, we'll have to assign this variable to a class property called as length, or there is a property called length in it. Like in other programming languages, we use length over here, int length and comma width. Like we use them to declare them as the members of that class. But in here, nothing of that sort will be happening. Okay, we can't do that. So if at all you want to do anything like that, that is not possible in Python, because only declaring variables and leaving them is not possible. This is the first thing I've dealt with while declaring variables in the first thing. So we can just assign them, and initializing our variables to some random values is not a very good practice. So what we do is we declare them in the constructor function itself, and we assign values to them. So this is why I told it's not a very good Python, is not a very good OOPS language, but let us just write the constructor function and leave it. Okay, we are not creating other methods and all. So as of now, the rectangle class will be having 2 properties, length and width, and it will have a constructor function which will take in 2 parameters, and it will assign those values to its properties. Now, how do I instantiate an object? Now, let me call my object variable as rect, and I'll be like rectangle of, and I'll pass in 2 parameters, 3, 4. Okay. Now, if I try to print rect, okay, let us see what I'll get. Okay, I get rectangle object and underscore main dot. See, underscore main, again, you might be seeing some Python programmers doing if underscore name equals to underscore main. This also I'll be discussing while I'll be discussing Dunda methods and all. Now I won't be doing it. Okay, so let us just see the type of it. Okay, we know we use the type function to see the type of anything, and here the type will be rectangle. Okay, since it's a user defined data type, the main will be appended over there or prepended over there. Okay. Yeah, cool. So that's the type of it. And now to access the properties of that object so here we did the instantiation. So this step is called instantiation. We have instantiated an object to the class. Okay. With width as 3 and length as 3 and width as 4. Okay. And self, though we are using it in the constructor function, here we won't be passing it. Okay. Because that self will be rect. Okay. I told I'll be dealing with self, right? What self is the object by which it went to the constructor definition. Okay, as I told you, same with functions. Constructor is also a function, but since it's declared inside a class, it is called as a method. Okay, so take it this way. Since it's a method, or it's a function to be precise, what is happening? It's a function call, right? It's nothing but a function call. So when a function call comes in, what do we know? It will go back to its definition, and it will do the work. Like that is what we have discussed in functions, right? And all the things that are declared under that scope will be done, and again the pointer comes here and we can continue with our procedure again. So what is happening over here is, if at all I go to the init method and I be like length equals to length and width equals to width, this length and width might be properties of our rectangle class, but to which object? Like every function call of rectangle 3,4, if at all I'm repeating it again and I be like rect2 over here and rect1 over there, and how does the interpreter know that this rectangle should go here and assign length and width of this object only and not to rectangle 2's length and width properties? Okay, because each object will have their length and width own length and width properties. Okay, we are just declaring them over here, but the rect1 will have length property and width property, and rect2 will also have length property and width property. And if you are just declaring this way and not using the self keyword over here, what happens is it will go and assign length and width, but it doesn't know to which object of that or which instance of that class should it assign those values to. Okay, so to the interpreter to be sure about that, we pass in a parameter called self, which is a default parameter, so we don't need to do it over here, and that will be defaulted to the object it is referring to. But like, what is the reason behind the scope going till here, coming to the init function? The reason is because we are instantiating. And which object are we instantiating? We are instantiating an object called rect1. So the self will be replaced with that rect1. So now rect1.length will be 3 and rect1.width will be 4. Okay. And in this statement, rect2.length will be 4 or 5 and this will be 6. Okay. Getting that? So it is as simple as that. It's if at all you know how this works, this keyword works in other languages, this is pretty much the same. But in other languages we don't pass this as a parameter, but in Python we do that. And the name of the constructor will be same as the class, but in here we use the dunder method called init. Okay. Now, how do I access these length and width properties? Same as we did with self dot, we can also use that rect dot, and you see that in the IntelliSense I get width and length. I can be like length. Okay, the rect1's length is 3, right? So now when I do this, I should get 3. Okay, we added some properties to rectangle class. Okay, and we wrote the constructor function, and we are using the constructor function to pass in the parameters and do stuff. Okay, that's great, but we can write things without writing the constructor function too. Okay, for example, I want to get a method called area. Okay, area doesn't take in any parameters, but what it will do is it will return that object's length into that object's length plus that object's width whole multiplied with 2, obviously. Okay, by the way, every method should take in the parameter self by default. Okay, to access the self variable inside that function, we'll have to pass in that as self, and this is a default parameter. While using this method inside with our object, we don't need to use that self parameter. Now, if I wanted to use that area method in our class, in our object rect1 object, you see that I get that area, and if I put the function call over there, like we want to get the area of rect1. Okay, so now self over here will be replaced with rect1, and we'll get 2 into L plus B, but L will be belonging to that self, which is again rect1, and width also will be belonging to that rect1. So now it will be 3 into 3 plus 4, 7, 7 into 2, 14 will be the output. Okay, that is the area of this rectangle. Okay, we can also have a perimeter where it will be like, okay, sorry, this actually should be a perimeter. I'm really sorry, guys. I was quite confused. Okay, yeah, so this is a perimeter. I can call the perimeter over here. I can also have the area, and it will be like self.length star self.width, because L into B is the formula for rectangles. This thing. Okay, so this is how we access methods and properties of our objects by using the dot operator and the name of them. And if the object method is having any parameters, we pass them through. Since it is not having any parameters, we are not passing it over here. Since the constructor is taking 2 parameters, we are passing them over here. Okay, and the self keyword is a replacement to the object we are referring to, and we can't just declare our length and width properties like class properties or instance properties just like that in other languages. So yeah, I know this sounds really confusing, because how can I just access the variables directly without declaring them in the class and all? But we can't just declare variables and leave them. So that is why I've been mentioning from the first, and that is what I'm telling now too. It is not a very good OOPS language, but some features of OOPS are really useful, of Python specifically, when compared to other languages. Okay. We can do like private variable. We can restrict the access of, like, for example, I did in the previous thing, I did rect1.length. Okay, like I could directly access the length, but if at all you didn't want to access that variable, if you wanted to put it as a protected or private variable, we can do that too. But even that, it will be having some drawbacks, and it is not completely a private variable, and even outside the scope of that class, we'll be able to use that. Okay, so there are some things, some loopholes and all in Python OOPS. So it is not pretty much a very good language to do that, but just that as this course is concerned, we are possible to do anything in Python using OOPS concepts. Okay, now yeah, so I written a method and I wrote some properties, and apart from the constructor method, I wrote other methods too, and I'm doing that. Great. Okay, done. Now let us create a subclass called square. Okay, because square is obviously an extension of rectangle. So in other languages, you might be seeing, in C++ we do that colon and we write public rectangle. Okay, in Java or JavaScript we use the extends keyword. Okay, but in Python we just pass that superclass. Okay, by the way, if you are writing a subclass, this is called a subclass, which will inherit all the methods and properties from there to here, so that now square will also have a length property and a width property and a perimeter method and a constructor method. Okay, and apart from that, if we declare anything new to this, they will be restricted only to the square and they won't be applied on the rectangle. So this is a subclass, and that's it, superclass. Okay, so all those will be inherited over here. So this concept is called inheritance. Okay, now I can just pass in the name of the superclass in the braces over there, right like that. So now square is a subclass of the superclass rectangle. Okay, now I can just be like init, and see that due to this extension, it directly did that to me. Okay, whatever I wanted to do. We can use a super method which will call the constructor method of the superclass. Okay, which will call the constructor method of the superclass, which is over here, this, and all these two statements will be executed over here, because super.init of length comma width. I can also be like rectangle.init. Okay, even that is the same, it doesn't matter, but it is a more cooler way to do this, and even this will take two parameters, length and width. But if you don't want that to happen, because square won't generally have length and width, right? It will have a side. So what I do is I'll pass in both the parameters as side, because rectangle, when it is having the same length and width, obviously it will be a square, right? So yeah, so now the super constructor function, the scope goes here, and both the parameters are side. So the length of the rectangle will be assigned to that side, and the length of the rectangle will also be assigned to that side, and we could get that over here. Okay, that's pretty much cool. And now I don't need to write a perimeter function over here, because anyways the same formula can be applied on a square too. It will be 4a, but in terms of, or 4 into length of side in terms of square. But even if we do the add 2 of the sides and multiply with them 2, we get the same thing, right? It doesn't really matter. I just wanted to show this how to do inheritance and write a subclass and all, and use the super method. So using the super method, I can access the, see what I can do here is I can be like self dot length equals to side. Okay, and I can pretty much be like self dot width equals to side. Okay, this is what I wanted to do normally if I'm having a constructor function of this sort. And or I can be like self dot side equals to side if I just didn't want length and width as parameters to my square class. But since I just wanted to demonstrate how we can extend a class with same properties, I just chose to do this. And instead of doing all this, I can call the constructor function of the super method, which itself is doing this for us. Okay, I don't need to write this code over here. So if I just do this, it will be the same. Now let me instantiate an object, sqr equals to square which will take in a single parameter, because you see it is taking in one parameter only, and let us take it as 3. Okay, now I can just print that square's length, width and perimeter. And now when I call the perimeter function over there and try to run that, rectangle object, oh sorry, I think, yes, there. Let me comment that out. I don't want that. Yeah, now when I run that, I get 12, because the perimeter of a square which is having 3 of length will be 4 into 3, which will be 12. Okay, so yeah, I'm not writing the perimeter function inside this method inside the square. It is just inheriting it from here, right over here. Okay, we can use it pretty much everything. And if at all I declare other methods in here, for example, there will be like area, okay, which doesn't take anything except for self. And what will it return? It will return self dot length, because that is what we are having, star, or no, I can just square that because both are the same. Okay, now I can also access the area property over here. Okay, but since I am having the rectangles over here, I can't be like rect1 or rect2 dot area. That is not possible. Okay, because area is just an extension to square class, and all the properties and methods inside rectangle will be here, but all the properties inside but the extra properties that we have discussed or declared here won't be applied in the objects of the rectangle class. Okay, so this is used for code reduction and all those purposes. Okay, so this is not possible. Cool. So yeah, I think that is it with the oops module, guys. So there are other things like decorators and passing arguments to decorators and writing getters and setters and deleters, and this is not a Pythonic way of writing Python oops code and all, because we don't use getters and setters and deleters in Python. In complete object-oriented languages like Java, we will be using these hectically. And I'll also discuss magic methods and under methods in the coming videos, and the static properties, like until what we have seen, the length and width properties are confined to the variables or like the objects we are creating, but we can also create some static properties which are linked to the class itself and not to any variable. Okay, we can't access them like rect1.length or rect1.width, but we can access them like rectangle.thing. Okay, so that is possible in by using static methods and properties. So I'll discuss all these in the coming videos. So let's meet in the next module. Okay, so now that we are done with oops, let's get into the 11th module, which is exceptions. Okay, so exception handling. We'll be using 2 to 3 keywords in here. The first keyword is try. Okay, let me comment this. Yeah, let me comment that, try. And then we have another keyword called except. Okay, and finally, and then raise. We have these 4 keywords to do exception handling in Python. Okay, so what is an exception? It is also known as a runtime error. Okay, for example, we'll be having some we'll be having some block of code, and before it we'll be having some code, and even after that we'll be having some statements. Okay, so if at all that is running into an exception or any error, we have seen many errors till now, like index range out of bound error, or trying to do mutable operations on an immutable data structure like sets and tuples and all. So those all are known as some exceptions, right? If we are going out of the index bound and trying to access something in a range function, or I've shown you many exceptions till now. Okay, and while concatenating too, if you are not typecasting an integer into string while concatenations, even that is an error, that is raising an error, type error. So these all are known as runtime errors or exceptions, because they will only be raised in some cases, and it completely depends on the user input. And the most important thing is they are done on runtime. Okay, there is no compile time in Python, but you can see some errors are being underlined. So those are known as compile time errors in Python. At least we don't call them compile time errors, we call them syntactic errors or syntax errors. But runtime errors are the thing we get only when we run the code. Okay, so for example, I have a variable called numerator, and I'll take an integer input from the user. Okay, for numerator. Okay, now I'll take the denominator from the user too, and I'll call it den. Okay, now what can I do? I can just print numerator divided by denominator. Okay, so that is it. When I try to run this, it will ask me for the numerator. I can give 5 and denominator is 2, and though it is not exactly divisible, we get the number out of it because this is not exception prone. So in how many kinds can we get an exception over here? The first kind is I get the numerator as 5 and the denominator to 0. Obviously, in mathematics or in programming, it is not possible to divide a number with 0. So we get an error called zero division error. This is there in the standard library. So it is a standard error. It is not a user defined error. It's a library error. So division by 0 is not possible. Okay, we get an error. So what is the drawbacks of having errors? If at all I have another line of code over here, print check. Okay, and when I try to run this, I give 5 and 0 and that won't be run. Okay, we get the input over here, and even see this line of code is not having any error in it, right? So this stops the execution of the program, the line by line execution, and hence all the code are written after that won't be executed, and it will be a terrible build fail in our coding. So how can we avoid this? The simple step is to have if else checks. Okay, so if denominator equals to 0, only then we'll print that. Okay, else what can I do? Else I can have a print statement which will be like can't divide with 0. Okay, now when I run this, I get the numerator as 5 and denominator 0, and oops, oh sorry, I am actually doing that in a reverse. I'll have to cut, paste, cut again. Okay, so now when I run this, I get the numerator as 5 and the denominator as 0, and we get can't divide 0. And the use case is, if at all I'm having another print statement over here which says check. Okay, and now when I run that with numerator as 5 and denominator as 0, I get the check 2 because the exception is being handled over here. This is one way of handling exceptions, but it is not the preferred way to do it because you can't precisely handle the error that is being shown to us because it's a standard library error and you want to execute it or you want to run it, handle it precisely, only that exception precisely and not the other ones. Okay, so there is a special syntax for that, and that is what we call as try and except blocks. Okay, so in the try block we'll have something like, let us say we have a variable called result which will store numerator divided by denominator. Okay, and in what cases will this throw an exception to us? Okay, when the denominator is 0, it will throw an exception, right? So I'll be like zero division error. Okay, except for zero division error. So we'll try to divide these, and so everything under this try block scope, whatever statements are there under this try block, the interpreter will try to interpret them and run them. And if at all we get an error over there or an exception over there, it will come to the except block and it will see where we have handled that exception. Here we are handling only the zero division error exception. So here what can I do is, can be like can't divide with 0. Okay, so that is what I want to print. Now when I run this and I give I have 5 and I have 0 and I get can't divide with 0. Okay, I can also have a statement over here where it will print the code after that, and I get 5 and 0, and even hello will be printed. Okay, so here we are not writing if else statements, but we are trying to do some sort of code, and if at all everything in that try block is raising exceptions, that will be handled in the except block. Okay, and that will be handled over here, but only a specific type of exception will be handled. What if I run this code, but this time I gave a string as my input, and obviously it is not possible, right? It is taking the integer input as a string, but we are trying to convert that string into an integer. Okay, the input function will take the string itself, that's not a problem. But when we try to typecast that string into an integer, which is not a numerical value in value, but it is having some characters in it, it can't typecast it, so we get a value error. So what we do is, since the error is coming from here, we were not able to handle it. So I'll cut that and I'll put that inside this block. Okay, see, the scope and indentation is very important in Python. You'll have to maintain it. So if at all we are getting a zero division error, this prints that. But before getting a zero division error, we have every scope of getting a value error, right? So for value error, what we will take is, we'll print enter only numbers, and yeah, that's all. Maybe, should enter only numbers. Like, it will just tell you what went wrong and all. Now when I run this program and I be like, again the same, Rahul, I get, you should enter only numbers. Okay, so we handle that exception too. So we can handle multiple exceptions over here. And the hierarchy of handling the exceptions, like we know if the value error is more prone or it should be handled first, then we push that into the stack and we put in the right after the try block. And if some error is very less prone to, some piece of code is very less prone and we won't be in generally getting that error and all, we put that to the down and all. If at all you want to write a global except block, like without any error, like it will handle all the exceptions. Okay, so it will be like print handling all errors. Okay, so what are all the errors that we can get from this program? What are all of them? Okay, for as of now, let us take this. Okay, because I just get that, and if at all I put a 5 and a 0 in there, I get can't divide with 0, because the error that we are getting by doing that is a zero division error, and that is being specifically handled over here. But if at all we are not handling every exception like that, and if I give Rahul over here, I go to, even though I'm not handling the value error in specifically, but this is a global except block which will handle all the exceptions and errors except for zero division error, because that is handled separately. Okay, so this global except should be always at the bottom, because if you're writing at the top, then the zero division error, you get that and it will directly go into that global exception block, because that accepts all kinds of exceptions. Okay, so you should never write it over there. If you want, I can just demonstrate that too. I'll just push this up there and you see that, by the way, you see, I get it here only, I can't even run that. Default except must be at the last. Okay, that's great. Cool. So that is what the line that we have seen, that is similar to compile time errors, or what we call as syntactic errors and syntax errors in other languages. Even here we can directly see while we are coding, but only when we are running some exceptions, those are known as, in the runtime, if you are getting some exceptions, those are known as runtime errors or exceptions. Okay, so we can also have a finally block, but I won't be discussing that, because finally block, and there is also an else block and try except blocks. So there is a difference between finally and else. I'll be not handling them right now and show how to do that now. So I should have done all that over here, but that's fine, I'll just move it. So I wanted to show normal runtime error exception code over here, and here I wanted to handle all that, but that's fine. Let's just put that over here. Cool. Now we can also raise an exception. So yeah, so that now we are done with exception handling, how can we raise our own exceptions? Okay, I'll have a try block over here, and let me just copy these over here. Okay, let me uncomment them. That's great. We have a numerator, denominator, and we are trying to store that in a result. Okay, but if we can raise it ourselves, the compiler will, or the interpreter will do that for us. But if at all we see that denominator equals to 0, okay, then I can be like raise a zero division error. Okay, so that from here the execution will stop, and you want the execution to stop. At times, we do exception handling because we don't want the execution to stop, but at times the programmer himself or herself, please don't make a mess out of it. Okay, I'm not a misogynistic person. So the programmer itself want to raise an error and stop the execution over there and not continue to the next things and all, then we can raise our own exception. We use this commonly to raise our own exceptions. Okay, And mostly we'll be using this for when we are dealing with modules and packages and our own data structures. If you're trying to implement a stack or a queue and all, if someone is trying to access a private variable, or if someone is trying to access something that is out of the range of the index and index bound and all, because you won't be using the common data structures like lists and all, right? So if you're trying to implement some hash table or whatever be it, then you want to raise some exceptions which will be raised in normal data structures, because our data structures are analogous to them. Okay, so we'll try to make a series out of it, a small mini data structure series where I'll be using the core features of the language to make them look simple and use the programming concepts to deal with them. Okay, so this is how we raise our own exception too if you want. So it will also have an except block, okay, a global except block where we can just write a pass statement. Okay, this is the most used thing in Python. We'll be using try catch blocks and we'll be using pass statements in try catch blocks, because if at all we are getting any error, then we just want the program to pass that, right? We don't want any error to be raised from that. It's a very bad practice, but at times you ought to do that. There are some scenarios too. Like I take a 5 and I take a 0. So now that when we run it, I have the numerator to be 5 and the denominator to be 0, and I won't see anything. I won't see an error being raised here because it is in the try block, and any exception that is being raised by the user or by the interpreter itself in the try block will be handled in the except block. And here I'm writing a global except block, so it will just be passed over there. Okay, so this I just wanted to demonstrate how pass works. But if I want that to be confined to only the value error and not the zero division error, and now when I run that and given 5 and 0, I get the zero division error. Okay, due to this raise division error method only. Okay, else it wouldn't have raised that. Okay, cool. So yeah, this is how we use exception handling and handle all the exceptions that we would be getting and writing a very exception prone code. The most important exceptions that we get here in Python language there are many of them. Value error and index out of range error and type error are the most common ones. So we can also write our user defined exceptions. Exception, there is a class called exception. We can extend it, and as I've told you in loops concepts, we can extend a exception class and we can write our own exception class and we can use that too. And as I've mentioned, there is a difference between the finally block and the else block, and while handling with try and except. So I keep saying catch because in other languages, most of the languages, we use the catch statement. Okay, and by the way, this raise is like similar to the throw keyword in Java. Okay, raise keyword. And so that's it, guys. Meet in the next module, which is maybe I think modules. Okay, the name of the module is modules. Okay, now that we are done with exceptions, we'll get into the 12th module, which is the modules itself. What are modules and all I'll be discussing in, and let's go through the task. It is asking us to write some utility functions in the library.py and use them in this main.py file. Okay, so this is the library.py, and I think I can open to the site. Yes, that's great. And I'll just expand it a bit. Great. So in the library.py, I'll write any function, any utility function. I can write anything, I can write constants and define variables with some values and leave them like that. And I can do anything, but as of now, I'll just write a function called square up, which will take one parameter called num. Okay. And what it will return is the square of that number. Okay. So that is a method that we have defined in that library.py. Okay. Now, if I want to print, square up from here with some variable called 5 or something, I can't do that. See, I get that exception over here, which is like undefined function. We did not define that function. So to use the function that is being defined in another file, which by the way are in the same folder, we use a concept called modules, and so now this will be considered as a module. That library.py is considered as a module, and I can use the import statement or the import keyword to import that module. Okay, now I can import my library. Okay, so inside that library I have the square up method, so I can access that square up method by using library.squareup. Okay, library.squareup, and it's a great practice to have two spaces between the imports and the normal code. Okay, even the normal code that people write you in that if name equals to main if statement, but as far as the basic crash course is concerned, we don't need to do that. I'll go through that in the later videos. So yeah, we are having print library of square up of 5. Okay, so this method of square up of 5 comes from the library. Okay, and that definition is in that library module. Okay, now when I run this, I get 25. Okay, that is quite possible in Python. Now what will happen if I have a square up method in here? Okay, which will take a number and it will just return the number itself. Okay, it won't do anything other than that. Now I run that, even now I get 25. Okay, because I'm accessing it with respect to the library module. Okay, library dot square up. I'm using the method in this definition and not here, so that is not a problem. And not only passing just literals to that, I can also pass the variable, and when I run that, I still get the same. Okay, that's great. So I can also use variables over here. For example, pi equals to 3.14. For example, this is the thing that I wanted to use over here. And now when I be like library dot, I have a pi and a square up both here. Okay, I can use the pi and I can print it, and I think I can just, yeah, now when I run this, I get 3.14. Okay, I can also access variables, and not only these variables, if at all I'm having my dictionary in there. Okay, I have the my dictionary. Okay, not strong with the typing. Okay, and I be like name equals to Rahul and age is 19. Okay, so now I can access that my dict, and I can access the items and keys and all from that. God, sorry guys, something's terribly wrong with my keyboard. Yeah, when I run that, I get name Rahul and age 19. I can access them too. Or if I just didn't want to do that way, and I can use the we have the keys list from there, and within the list I can access the first item. Okay, and I'll just typecast this into a list and then try to access it, and I get the name. Okay, I'm typecasting the dict case because dict case will give something similar to a list and not completely a list. Okay, I've mentioned in the other modules where in the data structures in dictionaries. Okay, when we went over here, I told it returns a list of tuples or list of values and list of keys, but they are not actual lists. They are dict keys, and there is a special data type for them. So they are very similar to lists, so we can access them, but we'll have to first convert them into, typecast them into a list, and then access the first or the second property and all. So I can, however, chained and indented there, however, inside the data structure there, we can access them like this. Okay, while importing and all. So now, if at all the name of a module is very long, like import library, and you're using library dot and all, we can write an alias for this. Okay, we can write aliases too. So now we'll rename our module. Now what I'll do is import library as lib. Okay, I'll import library as lib. Now what I can do, I can just print the lib dot square up of 7. So now I should get, I think I'll just comment these both. So now instead of writing the whole word library, I can just use the as keyword, so that this will be imported with a short name called lib. Now I can use wherever I wanted to use that lib. Okay, now when I run this, I get 49. But doing this is not possible, obviously, because you're not you're converting the name of library into lib, and you can no longer have the access to that name library. Okay, that is not possible. Great. So this is how we use the aliases while we have modules. This is called module renaming and short form. So there are many modules which we can use. So these are mod modules. We can import modules this way, and there are something similar called packages too. Packages is just like a collection of modules, and it has got a underscore in it, dunder method type of file, and it just constructs the complete package from a single module and all. So there's a lot of stuff. There's a lot of difference, and I'll be differences between modules and packages I'll be discussing in the coming videos, not in this video. And I'll also show you how to write a package, and we'll try to import that into the PIP and all. So for importing these modules and packages, we have something called the package managers. Okay, so these package managers, there are many in number. Like we have Anaconda package manager for Anaconda environments, PIP, which will or some people call it pip. Okay, so we use pip to import modules and packages, and we can use them in our native code. And we also have PyPen. Okay, and we can also create virtual environments and Anaconda environments and all, to have imports that are only to that version and have a different Python version to that. And this, so here is where we get into that thing that I've promised to demonstrate, which is setting up a Python dev environment. And I don't know when that video will be coming. It will be a very long video. I'll be discussing all the tools and all how to set up editors, and a lot of stuff will be there. So it will be a really big video. I'll be discussing everything in detail, so that you can choose your right tools, while I'll be giving a detailed explanation and a tour of all the tools that will be there. Okay, so yeah, so this is how we import. Normally we have many other packages, like third-party packages like NumPy, where we import NumPy as NP. Okay, and for example we have matplotlib. Okay, and there are other libraries too, like TensorFlow, which is used in data science and machine learning and all. We use that as TF. Okay, so yeah, that is pretty much it with using aliases. But there is also another way to import modules. Okay, before that, I'll just import standard library module, which is math. Okay, so what happens in the math module? So math is also a module which will have the functions that, as we have written in here, it will have other functions and some constants and all. I can use them over here. Okay, be like math dot, and you see that there is a constant called pi. Okay, when I use that, and I think I'll just comment these. It's great. And now we run that, I get 3 point all these numbers. Okay, so that's a constant in the standard library in the Python. So this is a default module. Okay, this is not a user defined module. And now if I just try to print that, I get a module over here, not a class. Okay, so whatever we define, we get a class, and the classes that we write, we get that main dot class name, and the modules, we get that module math. Okay, it's a built-in one. It's a built-in module. So this comes under the Python standard library. Okay, now I can use any method inside the math module. Okay, there are many. For example, I'm having the square root, where I'll pass in 16 over there, and when I try to run that, I get 4. Okay, so yeah, so this is a default method which will calculate the square root for us and give it back to us. Okay, so this, but as the functions and the constants and variables that we declare inside the module keeps on increasing, and the time of importing them, and it's very costly, and you don't want to do it many times. Okay, so that is where assigning functions and or classes and objects to other variables and concepts of that sort come in there. And that is where the video that I told I'll be doing on functions, the functional programming and first class functions, higher order functions, lambdas, that is where we get into them, so that we can reassign the standard library functions to something local, and so that it won't go and get the function definition of that, and the time complexity will increase. And by the way, while using modules, this folder, that double underscore pycache double underscore will be getting produced automatically. So it has got nothing to do with it. I think it just stores the history kind of thing, and what are the methods used till now, and now what is different types of methods we have declared over here, and it will be just using them over here. You can just clear that out, but every time you run and use a method out of this module, it gets created. Okay, so that's nothing, you don't need to worry about it. You can just include that while in your if you're trying to push your code to Git and all, you can just ignore that in the git ignore file. Okay, if at all you know how to use version control and Git and all. Okay, now this is how we import the standard library module. Some module related to the standard module. There is RE. There is, for example, we have many standard modules. There is JSON. You don't need to what I mean by the default built-in modules is that you don't need a package manager like PIP and all to import that module or import that package from the repo or from the source. Okay, you can just directly use the import statement in the name of the module, and you can write out that. Okay, you don't need to download it, use a version control thing, or package manager like PIP or Conda environments. You don't need to do anything of that sort. So that is what I meant by built-in modules. Now, yeah, getting to the from keyword. What is the from keyword? For example, I have two things over here, right? I have a square up and a mydict2. Now I don't want to import the complete module or library as LB or LLB, whatever. And then I'll be having access to both the square up function and the mydict object. So I don't want that to happen. I just want to use the square up function. So what I'll do is from library import what all are there. I think there is square up. Okay, we'll just import the method called square up from our library module. Now here there is a accessing the variables and methods differ over here, because you're not just importing the thing over here, right? You're not just importing the library, you are importing a method or something related to that, or something which is defined or declared in this. Okay, directly we are doing that. We are not accessing it with respect to this or using this. So there is no point or using in this math module or that lib dot and all. We don't need to do all that. So what I'll do is, now I can directly use square up like this, and I can pass a 5, and I'll just wrap it in a print so that you get to know what is going to be printed. And now when I run this, I get 25. Okay, here observe I'm not using something like library.squareup, because I'm not importing the library. I'm importing something that is inside the library directly. Okay, I'm not using that functionality or utility provided by that module with respect to the module's name. Okay, even here I can change that as keyword, so that now from library I'm going to import square up as function. So now the name of the function is not square up, but the name of the function is func, and this square up is coming from the library. So now here the square up word no longer will be in under use. I should use func over there. Okay, now when I run this, I get the same thing. Okay, so this is what we do. While most of the times we use this in some data science things, when we try to visualize something using data science, like matplotlib, we use a matplotlib to plot graphs and bar graphs and charts and all. There we will be using something from matplotlib, import pyglot or pyplot, and we'll be aliasing it using the as. Okay, yeah, that's pretty much it, guys. We'll see the differences between modules and packages in the coming videos, and I'll also show you how to write a package. And mostly I don't know, I'm sure, because even I'm working on it, how I'm trying to learn it. We'll try to import that to the standard repo and all. Okay, that's great, guys. So I think this is the end of it, and we'll go to the next module. Okay, now let's get into the final module, which is files. Okay, so yeah, in the final module files, I'm having two things. Text.txt is a normal dummy text file where I'll be having, I don't know which language this is, lorem ipsum dollar and all. There is a dummy text. We can just create that from within VS Code 2 if you want. There are some extensions for that. And I'm having a main.py file. Okay, so we can handle files like anything. We can open files, read them, write into them, or completely overwrite and write new content in them. We can read them byte by byte or line by line. There is a lot we can do, and we can also delete them, or if they are not existing, we can create them. Okay, there is a lot of functionality coming to the files API in Python, but the thing is, in this video I'll be discussing only opening and reading files, because writing and using complex methods on that, I don't think it is suitable for beginners and all. We'll get into file handling and modules and try except blocks in the single video in the coming series, so that it will be completely related to multiple files and organizing our blocks of code and all, so that while we are trying to publish some packages to the PIP environment and all, we'll be pretty sure how to do that. Okay, now how do I open a file? The problem is that here I opened this Python basics folder in my text editor, right? So the dot here, okay, as I told you, dot in Unix or any other operating system, even in Windows too, not only Unix, any operating system, dot refers to this folder, okay, the current folder, and double dots refer to the parent folder. Okay, so that is what, for example, if I open my terminal over here, and let me increase the size of it, let me go to desktop for simplicity. Okay, and on desktop, what are the things that I'm having? I'm having a blog and Python basics and all. Now I can go to Python basics, and now I'm in Python basics. Okay, that's great. But now if I want to see the list all the, use the ls command in Unix to list all the files and folders inside the folder, current folder, right? You use ls and you get all of them. But if I want to see what is there in the previous folder, I can just go back to that folder like this and do that. Else I can also be like ls this. So that double dot is the parent directory of this, which is desktop, and on desktop I am having all these. Okay, cool, right? Now similarly, we don't need to do this, but if I'm using a single dot, that means that I'm accessing this current folder, which is Python basics. In Python basics, I'm having all these. By default, even if I don't use a single dot, it returns me the same output. Okay, so the single dot here refers to, in any operating system, it refers to current folder, and double dots refer to the parent folder. That is why I write, code space dot, so that code is the alias to VS Code on any operating system. So when I press code dot, it opens VS Code in that directory. Okay, I can list that all the contents of the directory in the sidebar. Okay, so that is why I use code dot. Accessing text.txt, we have a function called open. Now I'll just name that file as my file, and what I'll do is I'll use a library function open to open a file. And it's a common practice to use double quotes while handling files. We can use the single quotes too, it doesn't matter, but I just like using double quotes only when handling files. For strings, I use single quotes. Trying to open it like this, text.txt. Text.txt. There are some modes of opening too. Like I can open this mode like in a read-only file, or write file, or only executable file, or I can open it anything. But by default, leaving it like this will open it in a read mode. But this won't work if you want to, let me be sure. I just want to print what is being opened in my file. If there is no error that is being shown, it is running, but it will show an error. It will be like file not found error. Why? I'm in the current directory and I'm accessing text.txt. It should be accessible, right? But it is not. So what we try to do is /, because we know that in the current directory, which is this directory, there is a file called text.txt. And so that when I try to do that, again I get the same error, file not found. Because here dot doesn't mean that this directory, which is files. Okay, here dot means the folder that I have opened in the editor. Okay, while coming to editors, the rules and all change. So what I do is, I'll go to that 13. I'll go to that 13 files folder. And then that, in the current directory, there is a folder called 13 files, which is this. And in that, there is a text.txt. Okay, I'm opening that and I'm saving all the contents of that into my file. Now, what I'll do, I'll just print what is there in that my file and all. I get a type. What is the type of that? It's a text type or wrapper, and the name of the file is this. I can click on it and, that will open here because I'm using the terminal and all. Now, and the mode is R, which is read-only mode. Okay. So we can open a file in any mode, and by default it will be R. Okay, so that is why even I didn't mention any read-only mode over here. It did open in read mode. So what are the types of opening modes and all? So we can open a file in different modes. For example, I have the R here to read. Okay, it's the default value. It opens the files for reading, and if the file doesn't exist, obviously we have seen here, because in the current directory, which is this, there was no file called text.txt, but it is something inside the 13 files directory, so it gave us an error. Okay, file not found error. I can just do this. The task here is to repeat the above task with specifying the mode. Okay, so let's do that. Why not? I'll copy and I'll paste that. And how do you specify the mode? Here I pass in R. Okay, where R stands for read. Okay, it's the second parameter to the open function. Now when I do that, I get again the same thing, the first thing and the second thing are the same thing. Okay, the mode here we are specifying it explicitly. We don't need to do that because that is by default in R mode. Okay, and there is also an X X mode, which is used to create. Okay, so it creates a specified file and returns an error if the file already exists. Okay, now what we'll do is we'll try to do this. Okay, and I'll just comment this because we don't need to explicitly specify that. And before opening a non-existing file, I'll just do that and I'll ask it to create it. Okay, now what I'm doing is create a file, so because the mode is X, and open it into a variable called my file. In which directory? In its current directory, in the 13 files, and name the file as 13.text.txt. But this will fail because it is already existing. So when I run that, it gives me an error, file exists error. It shows that this file already exists. So I can't do that. Now what I'll do is, I'll create a new file, okay? Like text2.txt. Now when I run that, a text2.txt is being created. So this is how we create a non-existing file. Okay, open a non-existing file. I should have done that here. So copy that, paste it. Okay, great. Now I'll comment this and I'll comment this too. Now, yeah, so these are the modes in which we can open. There is also a append and write mode. We can write into the file and all, but I'll be discussing them in the later videos. In this video, we'll only discuss about the 13b1, which is R mode, and 13b2, which is X mode. Okay, and we have created a file and we have opened a file and existing file too. That's great. Now coming to opening types. Okay, we have seen opening modes, but there are opening types too, like in what type you want to open it. If you want to open it in a text format, which is a default value by the way, so the text mode will be the default value and you don't need to pass it in here. Okay, so what we'll do is repeat the above task with specifying the mode and or. So what I specifically mean over here is, I'll just paste that, and no, not that, R, and I want to open it as a text file. Okay, I'll be like T. Now what happens here is, when I run that, I get the same thing. Okay, but here mode is R and in the form of text. Okay, I'm explicitly doing that. Even though I don't name it RT, it opens in T only. Okay, because that is the default value. Opening type is T by default. Since it's a text file, the txt file, it will open in the text file. Not only the txt files, I can open any Python files or in the T mode. Okay, in the RT mode. R is the opening mode and T is the opening type. Okay, now there is also a binary mode which opens in other mode. Okay, executable files and images, and for example images, we can use images to open in binary mode. So there is a task. This is a pretty very nice one to do. What I'll do is, I'll take source image equals to open, and I'll be like, it's in the images folder. I have two files, right? I have overview and series. I'll be like, in the images folder you have overview.png. Is it a PNG? Let me just check it out. Yep, that's a PNG, and the overview is capital. Okay, that's great. And as I told you, it should be wrapped in some parentheses. See, I'll be using the write function over here to write into the file and all, and what I'll do is other file, or this is the source file and it's the copy file that we're going to do, and I'll just create that file. Okay, where will I create that? I'll create it in the open, and I'll go to the 13 files folder. Okay, just I wanted to show you how to create a copy of a file which is already existing, and not just a text file, but I can create a copy of the file, an image file too, so that I can write it into that. So now I have other file.open /13 files, and what should I name it? I should name it as duplicate.png. Okay, that's great. I have a duplicate.png, and I'll be opening this file in the binary mode, obviously, because I want to write. I want to open it in the binary mode, and I'll be writing into it. Okay, so there is also a W, which stands for W mode, and even this file, I won't be opening it in the default mode. I'll open it in the read mode and in the binary mode. Okay, because see, source file, I'm not going to write anything in this, but I'm going to read the content of it in the binary format, and I'm going to store it in the source image. And what I'll do is, I'll just open the other file or create the other file. Okay, in the W format. And by the way, this W format, it doesn't need to write that X over here to create, though it is not existing, because the W itself creates a new file if it is not existing, and it will by default enter it into the writing mode so that we can write into it. Now what I can do is, the other file dot, I can use the write method, and the write method takes, what does it take? Write method takes a parameter of write a string to the file. Okay, we can use a string and we can write anything whatever we want. Now I'll send in the source image. Okay, now there is a method called write, and what I do is source image dot the read method, to be precise, because read is used to read all over the file. Okay, so this is what I'm doing. I'm using the source image in the read format, but in the binary format, because it's an image. I can't open it in the text format. and I'll have the other file which I'm going to create. By default, the W mode creates it, but again I'm going to create it in the binary format, and the duplicate.png will be created for us over here. And the file, whatever file which we open in the write mode, will have access to the method called write. And in the write, it takes one parameter, which will takes a bytes parameter. So in the source image, if I just can't pass in source image, because source image won't pass in all the bytes to it. To pass the bytes of the source image, I'll have to use a method called read. Now what it will do, it will read all the bytes in the source image and pass them as parameters to the write function, and it keeps on writing each byte into this other file which we have just created. So now when I just run this, I don't get any error over here, and if I go to duplicate.png, I get that file copied to us. So this is what happens in the background, and it creates something else. I know this may sound something complex because I've not particularly and precisely explained what this W mode is and how to create a mode and all, but discuss them in the coming videos. That's not at all problem. I just wanted to show you what all Python can do, and how good we will be using the Python tools and all to create copies of files and do that stuff and all. So we can write different Python scripts and we can automate so much of work that we wanted to do. Okay, so this is how we can create a duplicate image of the file, and by using the binary format. We can't do this if you are using the T opening type. Okay, so the R, W, A for append, and X for create, these are the right opening modes, and T and B are the opening types for text or for binary. That's great. Now we can read files too. Like I've just shown you how to read files. Okay, I mentioned it before, but we have read methods. What does this read method do? What I'll do is I'll just comment out all this. Okay, and I'll just copy that. Not do anything with that, and not do anything with this too. And come here, paste it in there. Okay, now I'm opening it in the read, and by default the text mode. That is default. I don't need to do it, but I'm just doing it. Okay, now that I've opened that for my file in the read mode and in the text format, what I'll do is I'll just take my str, my string, and assign it to a variable which is my file dot read. Okay, now the read function takes in some parameters, like it will take the number of bytes that it want to return, okay, or the number of strings or the number of characters that it want to return. Now if I type in 5 over here, it will read the first 5 characters of the file, which is this file, which is text2. Actually text2 is not existing, sorry guys, it should be text. Okay, there is a text2, but I think I'll be no, I won't delete it, I'll just leave it that way. Great, now I have my str equals to my file dot read and 5 bytes. Now when I try to print my string, not my file, I get lorem. Okay, why? Because it is reading the first 5 characters of that file, which is this. Great, right? Lorem, the first 5 characters are being taken into that, and that string is just giving that. If at all I'm not passing anything, it reads each and every character of that. Okay, it reads each and every character. Oops. Yeah, and it will print everything to the console. To that, everything, all that we are having in there. Okay, cool. So we can store this in a variable like this using the read method. So the read method takes in the number of characters that we want to read, or by default it will read all of them, and we'll do that. And there are other 2 methods called readLine and readLines too. What does these do is, for example, we have many lines in that file, right? In the text.txt we are having multiple lines. So for example, we want to read only 1 line from that. I'll just copy that and paste it over here, but instead of that it'll be like read line. Okay, what will this read line take is until a new line is being seen. Okay, until a new line is seen, it will be keep on reading that file. Where is the new line seen over here? It is seen over here, right? After the sequi there is a dot and then comes a new line. That is why the line number changed. Until there it is the same line number. You might be seeing these, this first line is in 2 lines because I have switched on text wrapping on in my settings. Okay, I can just put that off if you are a bit confused about lines and all. I'll that is called as word wrap, not wrap, it's wrap. Okay, word wrap to on, so that my things don't go off the screen. Now if you see, if I open that text.txt, you see that there will be one line and you'll have to scroll from like this to view that. I didn't want that, so what I do is I switch on that word wrap. So it will be pretty easy to read because I'll be having line numbers and I don't need to worry about whether the line is ending here or is it a new line and all, because I'll have the line numbers and I know where the new line is starting. Okay, so that's great. Now what I do is I'll read one line from that string and I'll just print that string until only that. So this is another method. In reading file section, we have the read method too. We have a read lines method too. Now I'll just comment this and run this. You see, till that sequi, I read all that and I'm storing it MyStr and I'm going to print it. That's great. And there is also a similar method called read lines, and let's see what that will do. Okay, read lines. And what does read lines do? Returns a list of lines from the string. That's great. So, but how many lines will it return? Yeah, I think this will read the complete file. Yes, it is reading the complete file. Okay, because we are not passing how many lines to read. So it is the same. If you are not passing any parameters, the read and the read lines are the same. Okay, but all these lines will be given to us in the form of a list. Okay, you see that? Let me. Yeah, so the first line till here is a string and that is taken into a list of, that's the first element of the list, and then comes the comma and the second line, and again here it comes to second, it's the ending of the second item of the list, and then comes the third item. Okay, but in the read it is like a single string that is being given to us, but here it returns a list of lines. And if I give 2 here, it will read 2 lines starting from the top. Okay, it will return as 2 strings over here. That's great, 2 lines from there. Okay, so that is for read lines. And what we can do is we can loop through an open file and print it through lines. Okay, so how do we do that? I have my file opened over here, and what I'll do is I'll read through for line in my file dot read lines. Okay, because read lines is a list and line is a single line or a single string in that list, and I can just print that to the console like this, line. Okay, now I'll have each line like this with a space in between or slash n in between, because by default a print statement will take a slash n as a end parameter. I told I'll be discussing separator and end parameters of the print function later. So yeah, so that is it, guys. We can looping through an open file. We can open a file and we'll loop through this. So this concept is used in the input and output things pretty much, and it gets in very handy while we are dealing with input and output. And I told you I'll be dealing with that in advanced input output functions, where I'll be dealing with strings and string format methods and string concatenations, advanced string concatenations, and what are the new features of Python 3.6 and 3.7, so that we can do advanced output and input things, and how can I take an array as an input and line of input, and I can convert them back into integers and floats and all. That's going to be a very competitive programming oriented thing. So yeah, there are notes here. It's a very good practice to close the file that we have opened. For example, we have opened the file here, my file, and it's a very good practice, it should be followed to close that file. Okay, we can close it. And now when we try to access other things like for example, let me do the same thing that I'm doing here. Okay, but we'll do that after closing this file. Okay, like my file is closed and it is no more opened in read mode. Okay, now when I try to read lines from that, I get an error. Okay, because IO operation on closed file is not possible. So it is safe to use that. If you want only some block of the code to open a file and then immediately close it, so that any other files or any line of code after closing the file, if you don't want that to access anything, it's a very good choice to close the files and make it a good habit. Okay, we have to close the open files always. And then the second note is we have the following modes which should be discussed, like append mode and the write mode. I've not discussed the write mode, but I told how to use it so that we can write it into the file. We can also use it to text files. I demonstrated to image files. And writing into files, we can use the write lines method. Okay, similar to read and read lines, we have, or read line, we have write line and write lines method. And there are Boolean functions like readable, writable functions. Like, for example, a file on your system is a dot file, or it's a hidden file, or in your operating system, or it needs a password to enter. Okay, like file permissions and will be there in that. So if at all it is having a read-only file, it's not a read-only, it's a read-only file, and you can't write onto it. And if you're trying to use the write function on that, it is not quite possible. Okay, though you try to open it in the write mode, you can't open it, because by default that file is having privacy issues and all. Okay, if at all it's a sensitive file. So there, what we'll do is we'll link up our Python scripts and some bash. Okay, bash, like we have change mode, chmod command to +x to convert into a executable file, and -x to take that out from an executable file. And there are many things to do with file permissions and all. So I'll demonstrate how to open write-only files or read-only files, and what is its relation with bash. If you don't know what is bash, bash is what I do to navigate through my terminal, and all the commands that I pass, ls and pwd and all these commands come into this. Okay, there are change mode commands too. And I'll also show you how to delete files and folders. Okay, if you want to delete a folder itself, or an empty folder, or a folder which is having files, or a folder having subfolders which are having other files and all. So we'll discuss all of these in great detail. So I think that is it for this video, guys. It should be pretty good to go and practice all these things. And I've taught many strings. If you want to just go through comments, and how can we use doc strings as comments, and also use them as multi-line strings and all in input output. How can we pass prompts to the inputs, and what is the dynamically typed language? How are we using the dynamically typed language like Python? And then we have the data types. I've covered complex numbers and all, and I told you there are some inbuilt methods like len and type and all. You can use them, and I can use the data types itself for typecasting using the constructor functions. And that is the same concept that we use in the data structures too, in the constructor. So that here we'll be using int, float, and complex to typecast, and here we'll be using list, tuple to typecast. And we are having membership operators, and normal operators, and string concatenations, and the identity operators, is and not is. What is the difference between them, all of them. And I have the conditionals, and here is where I've introduced you to scope. And we'll use these conditionals while we are going through loops too. In loops, we have the normal collections loops, or until the condition is satisfied kind of loops, and also iterating through a data structure, and range based for loops. And then I went through break and continue statements too. And then we have functions, and in functions I've not discussed too much. I should agree that, because I didn't want to make it very complex. I just wanted to show how to use functions in Python, and that's all. And I went to oops, and I've created a normal class. I added some properties to it. I added a constructor function and some other normal functions too, or methods to that. I've instantiated it. I've created a subclass. I've instantiated a method to an object to that subclass too. And I've shown you what's the difference between a superclass and a subclass, and accessing properties and code inheritance and all of them. And we went through exceptions too. We saw how to handle multiple exceptions or a single exception, and raising an exception when we wanted to do that, and how to try something that might raise an exception or exception prone code, and all of them. Then we went to modules. I told you what this PyCache thing has got to do, and also I explained a little bit introduction of dunder methods and all of them. So that which will be the difference between the packages and the modules and all of them. So from here, from modules and files, we'll be handling multiple files, right? We'll be having multiple files. In library, you have something, and you'll be accessing that in the main.py. And I told you how to alias the imports, and I also explained how to use the from keyword, where accessing becomes something special and all. Now we got to files, where I taught you how to open files and the types of modes to open a file, and the type of types to open a file. And then I created a duplicate image of it, and I told you how the path should be provided to it. I think it's a good practice to provide the actual path, complete path, than the relative path, because that would be very precise, and that would be the same for anything. And I've created copies of files and copies of images, and I've created a non-existing file and return into files. And I did not write to file. I just used it to show you what all you can do. But I've shown you the difference between readline and readlines methods, and I've iterated through all the lines of file in the list of lines of files. So that, and I told you that will be important in input and output too. Then so that's pretty much it, guys. So I know I've messed up some things and all. I could have maintained some great comments over here, and I can write some small helper comments and all. So what I'll do is I'll pause here and I'll write all those helper comments there, and each file I'll go through again, and in each file wherever I think I made some changes, I'll be writing some helper comments, so that when I push this completed branch to my GitHub repo, you'll see a very detailed explanation for everything that I did. Okay, so I think that's it for this video, guys. Okay guys, so that's it with this video. I've completed all the things, as I also gave the summary. Now a few changes before publishing this completed branch to the GitHub repo. What I added some documentation, and to make it clear, you can use triple single quotes and you can use triple double quotes. I've made some changes like this, and so that it will be easy for you to read while going through the both initial code and also the completed code. And one thing I want to discuss is this PyCatch I told you about in the modules thing. I added it to my gitignore file so that it won't be published to my repo. So that as you run that main.repo, your own PyCache file will be, PyCache folder, and this file will be generated to you. So I added to my gitignore, so it won't be added to my git repo while I'm pushing it. And the second thing is, well, coming to files, I'm not excluding this duplicate thing and text2.txt, which we have created by executing the main.py. But I advise you to delete both of them as soon as you clone this repo in the completed branch. Okay, in the master branch you won't be having these, but in the completed branch I advise you to delete them yourselves, or if you don't want to, you can just put them over there. And I mentioned it as a precaution in there too. Okay, so now let me open my terminal. Okay, and I was doing it in bash. Okay, so I'm going to desktop, and here we have Python basics. Okay, in the completed branch, let me run a git status to see. I'm having many changes. See that I have many changes there. What I'll do is add all the files. Okay, let me just close this thing over here, and yeah, now I'll commit. Okay, so now when I run a git status, I see there's nothing to commit, everything is being committed. Now what I'll do is I'll push it to my GitHub repo, and since it's the first time I'm doing it in the completed branch, not on the master branch, it's the first time I'm doing it, so I'll use that, and origin and the name of the branch completed. So it'll ask me for my username and password. Obviously you can't see me typing my password in there, and okay, let us see if everything, see, completed branch, and it is being set up there. Now when I go to my GitHub repo and just reload it once, and I see a completed branch over here, and when I open it, all my files will be there in that branch. Okay, so if you want, you can see, check the gitignore which got changed, okay, to all the modules, and that is not included, and you can go to modules and check if the PyCache is being included. No, it is not being included. That's great, guys. So you're having and even as I told you, in files you have these both two, duplicate.png and text2.txt. You can, after cloning this repo, you can just delete them, or in the master branch you won't be having them because I didn't create them. That's cool, guys. So that's everything that I wanted to do. So I'll be continuing this series, and exploring each and every topic, and making completely a specific video dedicated to each data structure, each data type, and libraries, modules, exception handling, and multiple files, and string concatenations, methods, and all. So I hope you're enjoying this series. I've not asked about this in the previous videos because I didn't want to. Please do subscribe and share with some coders, because people who can't code and all, they don't need to know about all this. There is no much point in trying to learn all this. But people who are interested and enthusiastic about coding and all, I advise them to, I request them and advise them, and I want you all people who are watching the videos at least to share if you think the content is awesome and all. So that is all with this video, guys. I know it's been a crash course, but it's been a very long and tardy crash course. So hope you're enjoying this. So I'll be leaving all the links and everything in the description below. So thank you, guys. Signing off. This is Rahul SriRam on the channel The Skinny Coder.